Good evening, all. Welcome to THiNC Institute of Design. So today we are starting a new program called Nata Sprint in our YouTube channel. Okay, so the Nata Sprint, this is exactly like a sprint. We are running through all the major topics from arithmetics, drawing, and we will be discussing GK and all the topics which we are very much essential for the success in your architecture entrance exam Nata. So we'll be covering each and every thing in a very quicker manner, and we will touch every nook and corners of the topic at our best. Okay, so I think Nata will be starting their exam by this week itself. Nata is at the doorstep. Okay, by tomorrow, I think they are starting April 6th. Okay, so today we are April 5, we are starting our sprint also in between. So in between the sessions, we will be getting questions of Nata. Like this is the first part of our sprint. By the second part or third part, we will be discussing the current questions. That means the questions on 5th and 6th. They had told that they will be giving the results by the next week itself. So these are the things they told and heard from them. So I'm not sure will they give it or not. We are expecting that they will be giving it. Okay, if they are giving it at the very next moment, we will be coming up with analysis of those things through the sprint, and we will be discussing those questions, and we will extend to connected questions of those things also for the upcoming exams. So I think we'll be getting a plenty of question papers in the course of time. So by the first 1 or 2 exams, we will be getting a clear clarity about the examination and their question patterns. And still we are believing that there will not be much changes as comparing to their previous exams. So the questions will be aligned. MCQs are going to ask, so the MCQs will be aligned with the previous year MCQs. And especially in arithmetics, we couldn't expect much changes, because the pattern of the question may be same for arithmetics, because from the years there is no scope to have much changes. So we will be discussing those arithmetics topics, and as a beginning today we will be discussing few, and for the next few hours we will be discussing arithmetics, and after that our faculties and other faculties will be joined like in the sprint, and the sprint will be somewhat like a marathon. Okay, anyway, the channel is going to continue this program for the entire length of the Nata entrance examination. So you guys can subscribe our channel, and you can click on that bell icon, so we will be getting exact notifications as the time. Okay, so I think we can directly get into the first topic of the Nata sprint. I will share my screen. Okay, 1 second, guys. So today we will be starting from the work time. Okay, so this is a tricky chapter, and since we are having exam tomorrow, it's better to start from a tricky one rather than starting it from a very easy topic. Okay, so we will be making this tricky one easy by today. Okay, that is the plan. So we wait for drawing and arc awareness. Those things will be starting in very few hours. So we will be directly get into work time chapter. Okay, so the work time chapter is a chapter which is going in an inverted way. If we think like in a linear manner, okay, but here we need to think in little bit different through the think. So over here, if A can do a work in 10 days and B can do the same work in 15 days, then how many days they will be doing? Okay, we will think that 10 plus 20, 15, 25. Okay, 25 days they are doing the work. Okay, the things are not going like that. Okay, the things are going in an inverted way. Okay, in an inverted way. So the entire chapter is done in the efficiency terms. Okay, the entire chapter is done in the efficiency terms. So we need to assess the efficiency before getting into the chapter. Okay, so A can do a work in how many days? 10 days. Okay, so for that, we need to find the efficiency of A. What is the efficiency of A? What is efficiency? Efficiency is his ability to do work. Okay. Anyway, what is the efficiency? If a person can do a piece of work in 10 days, how much portion of the work is done in a day? That is the efficiency. How much portion of the work done per unit time? Okay, so here a person can do a work in 10 days. So his efficiency is simply 1 by 10. Okay, so a person can construct a particular wall or a house in 10 days. Then in 5 days, half of the house is finished. Okay, so in 1 day, 1 by 10th of the house is finished. So what is done in 1 day is the efficiency. So 1 by 10. B is efficiency. Before that, why not to know how many days will B take to finish it? B is taking 15 days. B is taking 15 days. So what is the efficiency of B? Efficiency of B is 1 by 15. Okay, so we got the efficiency of both. So they are going to work together. They are going to work together. That means A as well as B is going to work together. The same work they are going to do together. So for that, we will club their efficiencies for a day. A's efficiency plus B's efficiency we will be doing. Then we will be getting A and B's combined efficiency. One and only equation in this chapter. Even we couldn't call this like a equation. This is just logic for solving the questions from this chapter. Not this. It is important. Okay. Convert the question into efficiency term. Do the question in the efficiency term. And return the answer in number of days by inverting. The important name or important word for this chapter is invert. Okay. Every time, keep this word in mind. Doing questions from 2 chapters, work time and pipes and cistern. 2 chapters, single word, invert. Single equation, A's efficiency plus B's efficiency equal to A and B's combined efficiency. The chapter is over. Okay. Now we need to know how to do the questions. Okay. The chapter as well as the equations are over. Okay, I will try my level best to deduct everything to a single equation or a maximum 2 or 3 equations in every chapter. We will try our level best. Okay. Some chapters demand more equations, but learning those what chunks of equations not good at this moment of time for the exam. So we need to limit it to the minimum. So over here, what is A's efficiency? 1 by 10. What is B's efficiency? 1 by 15. So what is their combined efficiency? Now we are going to discuss the combined efficiency. Okay, you can do it in 2 ways. You can cross multiply. You can just directly add this like 15 plus 10 divided by 10 into 15. Or you can go for taking an LCM of 150. Taking an LCM of 150. 10 and 15, you can take an LCM. But easy to take it like 30. LCM of 30 you can take. Or you can cross multiply this. Like this cross adds 15 plus 10 by 10 into 15. In this way you can solve. Different ways are with us. Okay, 25 by 150. Like 25 by 150 is like 1 by 6. Similarly over here, you can do like 1 by 10 plus 1 by 15, taking the LCM 30. 1 into 3, 10 into 3. You will be getting 3 by 30. So denominator is getting 30. Plus into 2. So numerator is 2, denominator 30. Okay. So I'm just given you how to convert that. So here it is 5 by 30 and it is also 1 by 6. So the efficiency we got is 1 by 6. But we are not satisfied with the efficiency. We need to convert it. Okay. Because this is the efficiency. We will be inverting. Invert it to get number of days. So 6 days is the answer. Okay. So this is how we are solving questions in this particular chapter, and other methods I'll be mentioning in the course of time. And you guys can put your responses in the chat. Okay, I can find a plenty of messages in the chat. Okay, you guys can put your responses in the chat, live chat. So you'll be getting a feel that you guys are sorry, you guys are writing an examination. So your brain will be getting an intimation that you guys need to solve these questions in a very short time in the upcoming days. So just practice it from here onwards. A doubt from the JD, will there be a curiosity this week? Definitely there tomorrow. Okay, tomorrow you can expect a curiosity. Okay, I will be taking you to the next question. 3 persons, A, B, and C can do a piece of work in 12 days, 15 days, 20 days respectively. Then how many days will they take to complete the work? Okay, if they are working together. So you guys can put your responses in the chat as quick as possible. I will be looking into your answers in the chat. So exactly same how you solve for 2 days. Sorry, 2 persons. It is over here. So find the efficiencies for the 3. A's efficiency, B's efficiency, and C's efficiency. And you can directly do it from the question itself. Okay. And limit it to limited number of steps and solve it. Okay. Tuk, I'm looking for your answers. Take the LCM. You can, in this particular case, you can take an LCM of 60. You can take an LCM of 60 because 12 here, 15 here, and 20 here. You can take an LCM of 60. And with that, you can easily solve this. It will be like 5 plus 4 plus 3. That is 12 by 60. Okay, we are doing it in mind. Okay, mind voice is getting into you. Okay, my mind voice is getting into you. Actually, I'm not at all writing anything. I'm just telling you that take the LCM 60 and it is like 5 plus 4 plus, that is 9, 9 plus 3, 12. And it is 12 by 60. It is 1 by 5. The answer is 5. Okay. So we can do this thing in mind and I will show you how to solve it in paper. But we can simply tell the answer like this because we have the numbers. So next I'm going to solve it through the efficiency method here. A's efficiency plus B's efficiency plus C's efficiency equals A, B, and C's combined efficiency. So here 1 by 12, 1 by 15, 1 by 20, and I'm sorry, 1 by 20, and the denominator is 60 here. So here you can multiply with 5 to get the denominator 60. So it is 5. To get the denominator 60, you need to multiply with 4. Therefore, the numerator 2, denominator by 3, and numerator 2. So 5 plus 4 plus 3. This is how we were discussing these things earlier too. So 12 by 60. And it is 1 by 5. So what we need to do next, we got an answer in invert terms. So we need to invert it. Efficiency term, we are getting answer. So invert it to 5 days. Enough. Okay, 5 days. So the right answer is 5 days. So let's try the next question. A can build a wall in 15 days. B can build it in 10 days. While C can completely demolish the wall in 12 days. Okay, a person is constructing. 2 persons are here constructing and one is doing the destructive work. And if they start working at the same time, in how many days will the work be completed? Okay. So you guys can try this question. A negative work concept has been involved in it. So who is doing this demolition, take its efficiency, but in a negative way because he's doing not a constructive work. Okay, he's just destructive work he's doing. So take it like a negative one. Okay, like negative 1 by 2, 1 by 12. That is his efficiency. Okay, so 1 by 15, 1 by 10, minus 1 by 12 will be the steps. And here you can take the LCM like 15, 10, 12. Again, 60 you can take. Okay, 60 you can take the LCM. And the numerators will be like 4 plus 6 minus 5. Okay. So again 5 is coming, isn't it? 4 plus 6, 10. 10 minus 5, 5. 5 by 60. And you can easily cancel these things. Okay. 1 by 12. So now we are going to do this question. So I can build a wall in 15 days. That means I'm not getting into detailed steps. 1 by 15. That is A's efficiency. What is B's efficiency? 1 by 10. First two step questions, I just had a detailed explanation. So we will be reducing it 1 by 12. Okay. So we need to gradually elevate our skills. That is why I'm just limiting the number of steps here. If you guys want more steps, you can put it in the chat. I can directly see your live chats. So based on your request, we will be increasing the number of steps and reducing the number of steps based on your request, everything. Okay. So over here, you can take the denominator, as I mentioned earlier, like 60. This is the LCM here. So 1 by 15 become 4 by 60. 1 by 10 becomes 6 by 60. And 1 by 12 becomes 5 by 60. So it is 4 plus 6, 10. 10 minus 5, 5. 5 by 60. So 5 by 60 is 1 by 12. And the crucial step, that is invert. Okay, we can only do this question by inverting. So it is 12. Keep it at your mind. Okay, so if the question is given in a number of days, okay, just invert it before solving the question. Just invert it, find the efficiency, and when you find the efficiency at the end, return it. Okay, return it like another inversion. So invert is very much important in this chapter. So let's move on to the next question. And I'm waiting for your responses in your chats. A and B can do a work in 8 days. A alone can do it in 12 days. In how many days can B alone can do it? So earlier we see that A can do it in certain days, B can do it in certain days. We took their efficiency for the combined efficiency. What is given in this question? Combined efficiency has been given in this question. Okay, combined efficiency is provided in this question. So we have the efficiency for the A. So we only need to find the efficiency for B. That is enough. So if you find for the efficiency of the B, the very next moment, invert it. What you want is there. Okay, I have given you the steps and I'm just looking for your responses in the chat. Actually, we are having a crash batch, which is in between you solving the question. Just pay attention to this also. We are starting a crash batch, both online as well as offline by the upcoming week. So we will be having an online batch by April 8. Okay. And after that, we will be having by April 15 also. Okay. Similarly, we will be having an offline session starting from April 15. We will be having offline, and offline centers are throughout Kerala. We have offline centers at your reach. Like you can find it in Calicut, Malappuram, Thrissur, Ernakulam, and Kollam, Trivandrum. Plenty of offline centers are also there. Okay, depends upon your comfortability. You can join as well as offline or online. Okay, and for more information, you can find the numbers in the chat over here. Okay, so we can get into the answer. So A and B can do a work in 8 days. So do it with me, guys. Okay, it will be better because we don't have much time. So utilize this time with a pen and paper on your side. So solve these questions along with me, because after this video, if you want, you can revisit these things, but we have only limited time. So try to solve everything with me like you are sitting in a classroom. So we are trying our level best to provide a similar experience also. But you guys know that offline is offline, and dedicated mentoring will be there for the online itself. So you will be having dedicated mentors and coordinators who is talking to you and addressing your each and every issues. For those kinds of supports, you can use the numbers over here. And A and B can do a work in 8 days. We are getting into our question because over here, A's efficiency 1 by 8. Okay, so we have the formula A's efficiency plus B's efficiency equals A and B's combined efficiency. So let's see here, A's efficiency 1 by 8. I'm sorry, A's efficiency is 1 by 12. And we don't know the efficiency of B. Keep it like that, simply B's efficiency. And combined efficiency, we know that it is 1 by 8. Because A and B can do it in 8 days. That means the 1 by 8 of the portion is they are doing it in a single day. Okay, so just take this 1 by 12. The other side, we'll be getting the B's efficiency. 1 by 8 minus 1 by 12. If we are getting a positive value, he is doing a constructive work. And if it is negative, he is demolishing destructive work. So you can take LCM or you can simply cross and solve this. So over here, if you go for taking an LCM, you can take like 24. Okay, so if you multiply here, you will get denominator 24. So same on the top. So 3, similarly go for 2, minus 2. Oh, it's 1 by 24. 1 by 24. So that means if you invert this, what you are getting? 24 days. Who is taking this 24 days? B is taking this 24 days. Okay, so B is taking 24 days. Okay, and if the person, I'm going to, KJ, I'm going to employ this person, these two persons. Okay, A can finish it in 12 days and B can do it in 24 days. Who will be earning more? Who will be earning more? Okay, obviously, based on the systems profiling in over here, person who is getting finishing it in 12 days will be getting lesser amount, and person who is taking for 24 days is getting more amount in our scenario. But amount is divided on the basis of efficiency actually. So if A is finishing our work in 12 days and B is finishing it in 24 days, the amount will also be distributed like that. Okay, Jayant. Okay, amount is also distributed in this way. So how to convert this into now numerals? Okay, actually we are having it like fractions. So I'm just multiplying with the 24 to out. So multiplying 1 by 12 with the 24 and 1 by 24 with the 24. I'm multiplying it with the LCM. So it will be like cancelling it, 2, cancelling it, 1. So 2 is to 1. If 300 rupees is there to distribute among them, we are giving 300 rupees, then A will be getting 200 and B will be getting 100. Okay. So this is how we are distributing money. And we always think that the person who is doing 24 days and the person is only doing for 12 days is not like that. The money is for their ability to do work. Since they are doing work together, only 100 rupees will be given to B if there is 300 rupees. Okay, if there is a 900 rupees, then 300 for the B and 600 for the A. This is how the amounts are distributed. Jayant want me to explain this problem once again. Jayant, actually I'm not we'll be just discussing about a question, and I'm just extended that question to some other levels of distributing their money. Actually, that thing is coming under the topic of ratio and proportion. Anyway, we'll be discussing that thing once again later. So in this question, the demand of the question is A can do a work in 8 days, and sorry, A and B can do a work in 8 days. Two peoples can do it in 8 days. Okay, and one of them can do it in 12 days. So we have our basic equation. This is the basic equation. So A can do it in 12 days means A's efficiency. Efficiency is inverting. Okay, Jayant, we will be inverting it for the efficiency. So A can finish it in 12 days means A's efficiency is 1 by 12. We don't know the efficiency of B. If only we know the efficiency of B, then we will be knowing that how many days he will take to finish the work. So combined efficiency is 1 by 8. So B's efficiency is equal to just taking this to the other side. 1 by 8 minus 1 by 12. Okay. So 1 by 8 minus 1 by 12, that is 1 by 24. So B is finishing the working 24 days. That's it. Okay. So we are getting into the next question. Solve this. This question involves some negative work concepts. A completes a work in 12 days. No, so negative days, not remaining work concept. And B completes the same work in 15 days. So A started working alone, and after 3 days, B joined them. How many days will they now take together to complete the remaining works? Okay. So now you guys can solve this question, and we are solving remaining work questions in a different way. Okay, I will tell you how it is. We will be using another way for solving the question. And before that, I will explain an earlier question in that method. So we can do the first question in that method. First question, I'm going to explain it in a new method. Okay, a second method. And that method we are widely using for solving questions of what? Remaining work problems. So I will explain that method over here. So A can do a work in 10 days and B can do it in same work in 15 days. Then how many days will they take to complete the work? So let they finished the work in next days. You guys know how to solve this question using our traditional way, like efficiency method. And one more way we are going to learn now. Let they finished the work in X days. This is we are learning in connection with learning remaining work. Okay. For learning remaining work, we need to know how to solve it in this method. Okay, because this will be easy. So over here, let they finished the work in X days. Then as I mentioned here, 1 by 10 is the efficiency of A, and 1 by 15 is the efficiency of B. So how much portion of the work is done by A in 1 day? A finished 1 by 10 in 1 day. Okay, this is the case of 1 day. In 2 days, how many portion he's done? How many portion in 2 days? He done 2 by 10. Okay, 1 by 10 plus 1 by 10 or 2 into 1 by 10. In 3 days, how many? 3 by 10. In X days, how many? X by 10. So the work done by him in X days is, or his contribution. His contribution for X days is X by 10. His contribution for X days is X by 10 by A. By B, his contribution is again X by 10, X by 15. Because he is doing 1 by 15 a day, 2 by 15 in 2 days, X by 15 in X days. And what will be the result if the 9 days, if A is working alone? 9 by 10. Okay. What will be the result if 10 days A is working alone? 10 by 10. 10 by 10, that is unity. That means the entire work is unity. So here, X by 10 plus X by 15 equal to 1. And by taking this, if you are solving for X, then also you will be getting the answer. X is 1 by 10. X into 1 by 10 plus 1 by 50. I took the X as common. So it is equal to 1. So X into 1 by 10 plus 1 by 15, we had already done here. I'm just taking it 1 by 6. So it is equal to 1. Implies X equal to 6 days. So keep this method also, unity method, okay, or unitary method also there. So 2 ways for solving the same question. This is the way usually we use for similar questions, but this is we are using for remaining work questions. I will tell you how to use it in remaining work questions. Okay, so just take screenshots if you want in between. So here, let's use that method over here. A completes a work in 12 days. B completes the same work in 15 days. A started working alone, and after 3 days, B joined them. Sorry, B joined him. How many days will they now take together? How many days will they now take together to complete the remaining work? So we need to assume that let the work finished in X days. Assume finished in X days. So A completes the work in 12 days. B completes the work in 15 days. So we got the efficiency of A 1 by 12. Efficiency of B 1 by 15. A started working alone and after 3 days B joined. That means A worked for the entire period of X. A worked for the entire period X. But B didn't work for X days. He worked for X minus 3 days only. A worked X days and B worked X minus 3 days. And the demand of the question is also finding X minus 3 because A and B worked together for X minus 3 days and B was there for X minus 3 days. But A was throughout there. Okay. From the beginning to end, A was doing the work. So X by 12th portion of the work, X by 12th portion of the work is entirely done by A. Similarly, X minus 3 by 15th portion of the work is done by the B itself and its contribution. Okay, contribution of A and contribution of B we had seen. It's equal to unit. That is 1. Okay, entire work is 1. So now we can solve this question like 15x plus 12x minus 36 divided by 12 into 15. 12 into 15. I'm just simply writing like 12 into 15. Keep it here. Okay. And coming over to the next step. 15x plus 12x, that is 27x. 27x, it is equal to 1 actually. Okay. 27x minus 36. That is equal to 12 into 15. 12 into 15 is like 150, 180. So 27x. So over here, 27x equal to 180 plus 36. That is 216. That is 27x. So x equal to 216 divided by 27. You can divide this with 27 because 27 into 8, that is 216. So x equal to 8. Is the question is over. Somebody tells that believes that the question is over, but it is not like that. We want remaining work. How many days? We want the remaining work. So answer is x minus 3. Whenever we find it, we will go for ticking this. But the right answer is 8 minus 3, that is 5. The question is for finding how many days will they now work together to complete the work. Okay. So 5 is the right answer. Okay. So keep it in mind, these kinds of tests in the question. Binu, I can see your answer. Very good. Great. So for admissions for the April 8th online batch, you can use that number. And we will be starting April 15th. Very next day in Kerala, there is a festival called Vishu. Okay, by very next day, by April 15th, we are starting our new batch for the Nata crash in the offline also. Okay, for online, you can join by 8th April. You can use the number over here. And let's move to the next area. We were discussing about work time. Okay, work time is getting the formulas and everything is same here. And we are getting into the new topic, that is pipes and cistern. Pipes and cistern means pipe and tanks. Okay, pipes and cistern. Here also, nothing is different. If A can do a work in 9 days, or A can do a work in 2 days, here A can fill a tank in 2 hours. Okay, we have a tank. A can fill this tank in 2 hours. And in 1 hour, what will be the portion filled? Half of the tank is filled. That is the efficiency. Work done in unit time. So over here, it is 1 by 2. Okay. If I can finish a thing in 2 hours. So what we are using here, we are using invert. We are using invert. Just invert and use. If I can do it in 2 hours, invert. A's efficiency we are getting 1 by 2. Okay. So efficiency we have 1 by 2. Invert it. We are getting how many hours will he take to finish it? Okay. See, same, exact same, ditto to work time. Okay. So connected chapters. That is why we are solving it together, because we'll be getting 2 questions from these 2 chapters. And this is not actually 2 chapters. This is 1 chapter by their essence. Here also we are using the same. A's efficiency plus B's efficiency. That is A and B's combined efficiency. For the remaining work also we are using the same thing which we learned in the previous question. So let's see through the questions. You will be getting a clarity. If a pipe fills a tank in 6 hours, I will be looking for your answers. Jayant and Binu, I just saw your answer for the previous question, and for all, I'm looking for your answers. If a pipe fills a tank in 6 hours, then what part of the tank will fill in 1 hour? Demand of the question is efficiency. Find the efficiency and put it in the chart. I just want the option A, B, C, or D. Looking for your responses in the chat. So if a pipe fills a tank in 6 hours, then what will be the efficiency of that pipe? It is simply 1 by 6. How will you find it? By simply inverting. Inverting will give you marks. Let's try the next question. If a pipe fills a tank in 4 hours and another pipe can empty, what is this? This is negative work. Destruction. Destructive. Okay. We are losing it. So this is negative work. So negative efficiency. Solve it. Negative efficiency. If a pipe fills a tank in 4 hours and another pipe can empty the full tank in 6 hours, when both pipes are open together, then find the time required to completely fill the tank. Okay. So if you are going to be good at these things, then you can find that in what time your water tank at the home is filling, and it will be getting empty. Okay. And don't try these things at home by putting a hole in the tank, and never blame me for that. Okay. So if you want, you can try those things, but these things are not for the experimental purposes. So injurious to health by the parents. Okay. So let's see. If a pipe fills a tank in 4 hours, so efficiency will be 1 by 4. And empty it in 6 hours. So here the efficiency is minus 1 by 6. So what we are using? We are using the regular formula. A's efficiency plus B's efficiency. One and only formula for 2 chapters. I can't reduce this beyond this. Okay. I can't reduce formulas beyond this. Same formula for 2 chapters. And fine. Okay. So A's efficiency plus B's efficiency, that is equal. I think Jayanti is a few minutes delayed. So you can come to the exact live position. Okay. So A's efficiency, we know that is 1 by 4. B's efficiency, that minus 1 by 6. And the combined efficiency, that is, you can take an LCM of 12. Simply took an LCM of 12. So this is 3, this is 2. So 3 minus 2, 1, 1 by 12. Invert for your required answers. Invert 12 hours. Okay, 12 hours. So that is the question. That is the answer. Okay. KJ, fine. So I think you guys are putting answer for the previous questions. Just come to the exact live position. So let's move to the next question. A pipe can fill a tank in 20 hours. Due to a leak in the bottom, it is filled in 40 hours. If the tank is full, how much time will the leak take to empty it? So we need to find the efficiency of the leak. Okay. How we get LCM 12? The doubt is from Nishwa. So let's see here. 4 and 6. You guys solve the question in between. I will be showing LCM of 4 and 6 over here. Okay, for Nishwa, I will do it here. So others can do this question. Nishwa, LCM. So coming to live sessions are, this is a benefit. Even for looking into the recordings, you can't ask me doubts directly like this. Okay, but if it is live, if you are coming, you can ask like this, like Nishwa asked here. So LCM of 4 and 6. So first of all, I will find the multiples of 4. Okay, multiples of 4 are 4, 8, 12, 16, and so on. And multiples of 6, that is 6, 12, 18, and so on. So the LCM over here, the least common multiple, that is 12. So LCM of 4 and 6, that is 12. This is one way of solving this. Next, prime factorization method. Okay, so 4, 6, and coming over to here, just take the first prime number 2, then it is like 2, 3, then go with again 2. So over here 1, but we can't touch the 3, simply take the 3 here. And again for 3, we can't touch 1, simply take 1 here, 1. So when you get 1, 1 over here, this will be the LCM, 12. Okay, this is the two ways of getting LCM, Nishwa. And how I am getting LCM, okay, 4 and 6, I will be going for multiplying 4 into 6, 24. Okay, so I will be thinking that 24 is the half of 24, 12. 12 is also multiple of 4 and 6. Okay, so it will be going with 12. I will try for 6, half of that I will go ahead, but it is not working. So I will be fixing to 12. All these things are happening in my mind. Okay, since we are having, when we solve question, and you guys, when you guys get experience in solving questions, these things normally come into your mind that, okay, LCM or a multiple of LCM easily come in your mind. Simply multiplying through that, you'll be getting a number. Half of that or 1/4 of that will be the LCM. Okay. Nishwa, welcome. Okay. So I know that everyone is having issues with taking LCM, and I won't be explaining LCM this session because we only have limited time. Even though we are having exam tomorrow, that is why I had given an insight into LCM. Actually, in the sprint, in the upcoming days, detailed LCM and HCF sessions are coming. Okay, so stay tuned to our channel. You can put the bell button on for those sprint sessions. Okay, so over here we will be solving this question now. A pipe can fill a tank in 20 hours. KJ will be looking into it. Okay, a pipe can fill a tank in 20 hours. So we have the efficiency of A. I'll be going for 1/20. We don't know about the leak. So we will be taking the leak like B. So B is efficiency. So it is filled in 40 hours. So 1/40 is the combined efficiency. Let's solve for B. So you will be getting a negative value. Negative means it is a destructive work or a negative work. So over here, you can take 40 and 20, you can take the LCM 40. Okay, 40 and 20, you can take the LCM 40. So over here, 1 minus 2/20, 1/20 become 2/40. So it is minus 1/40, and as like KJ told, 40 hours. Okay, time is not having any negative values. Okay, so 40 hours. The efficiency is having negative, but we don't need to bother that. Okay, 40 hours. Things are simple and solved. Let's try your next question. I'll be looking for your live chat. Okay, I'll be looking into the live chat, and I want responses over there. We need to have an active participation, and I wish to take these things like my exact online class. I'm trying my level best for that. Okay, so be here in the chat boxes for giving me live impressions on your live answers. Okay, so through that we can exactly conduct it like our live class in the classroom itself. I wish to give you like a feeling that we are inside the class. So I want your active participation for that. Unless these things will be going pretty boring. Okay. So we need to be actively engaged, not passively. So I want your active engagement. So KJ, a pipe can fill a tank in 10 hours, while another pipe can empty it in 6 hours. If you guys want any topics to be discussed over here in the sprint in the upcoming days, please do let us know through our comments. Okay. Based on your comments, we will be filter the topic and priority, not only for the arithmetic, but also for all other topics. So your comments, we will be filter the topics and we will give the priority and coming over here. Okay. So for my next sessions, my active students can comment in the chats regarding what you guys want in the upcoming days. Okay. So we will be prepared for those things. So a pipe can fill a tank in 10 hours. Okay. A's efficiency is 1/10. Another pipe can empty it in 6 hours. B's efficiency, Nishwa, minus 1/6. Okay. Find the time taken to empty the tank. Okay. Time take to empty the tank. A's efficiency plus B's efficiency. I don't think that repeatedly writing the equations are not required. 1/10 minus 1/6. And over here, you can take the LCM 30. Okay. Take it like 30. Or if you are finding it difficult, take it like 60. Okay. I don't have any issue for that. 30 or 60. Go ahead. So this is, I taken 30. So this is 3 minus 5. Okay. 3 minus 5. That is minus 2/30. So it is like minus 1/15. So time is not having any negative values. Invert and find your answer. Okay. 15 hours. KJ, good. Great, KJ. Okay. 15 hour is the right answer. So let's try the next question. Through an inlet, a tank takes 8 hours to get filled up. Due to a leak in the bottom, it takes 2 hours more to get it filled completely. That means 2 hours more means 8 hours plus 2 hours. That is 10 hours it is taking. That is a common sense what we need to have in this question. Okay. So if the tank is full, how much time will the leak take to empty it? So efficiency of the leak is our priority. We need to find the efficiency of the leak. Then we go for solving this question. When you get the efficiency of the leak, simply inverting, you are getting the answer. Okay. So when you finding the answers, I will be giving an insight to the courses. We are starting it by April 8. You can join through the numbers provided in the chat. You can find it over here. And you can use those numbers for asking queries regarding Nata. Like what is the trend of questions? In the upcoming days, we'll be making question analysis. And you can ask for the trend of questions and each and every doubt related to Nata. You can use these numbers to call. Related to last day, a few students used to call us regarding their exam center allocation. For the Saturday examination, one of our person who had queried for a person asked like he only get that admit card by, I think this is Friday, Thursday. Okay. For the Saturday, he got the admit card by Thursday. And I was having an offline session. So just through my colleagues, I just came to know that one student got an exam center. He is actually from Malappuram. Okay. The person is actually from Malappuram. And he got the exam center in a place called Mallappuram. Okay. The name of a college, certain college, like ABC College, Mallappuram. Okay. Actually, that particular college is situated in Malappuram district itself. That ABC college is in Malappuram. But the Mallappuram is the place in Tamil Nadu. Okay. Malappuram is in Kerala and Mallappuram is in Tamil Nadu. So we can assume that may be a spelling error. Okay. So his location is given like Malappuram. So we just conclude that, okay, there is an issue. Actually, it is in Kerala. Okay. So Malappuram is in Kerala and Mallappuram is in Tamil Nadu somewhere. The ABC college. Okay. I'm not giving the exact name of the college. The college ABC is in Malappuram, but the address for the college was given in the state of Madhya Pradesh. Okay, ABC College, Racecourse Road, I think some other local names, and the place is given like Madhya Pradesh. So that was the address. So he got confused. Go to where? Okay. So is these kinds of confusions if arise between you, you can feel free to contact us as well as Nata people. Okay. So if you call us, we will be guiding you how to approach this issue. Okay. Or you can directly call the Nata people also. So just everyone take your hall tickets and just have a look. Okay. Just have a look. The exam location center and everything. That will be better at this moment. Okay. So simply downloading, and maybe someone is planning to download it by tomorrow morning. Okay, because I have the laptop, I have the printer itself, so I'll be downloading it and printing by tomorrow. I think better to keep it today, because if you have any queries, you need to have the space to ask and solve it. Okay, better for that. So read each and everything in that hall ticket. So look into the question. Through an inlet, a tank takes 8 hours. Okay, A's efficiency is 1 by 8. B's efficiency is unknown. Who is B? B is a leak. And its combined efficiency, it takes 10 hours to get filled. Okay, so after filling, we just closing the its inlet tap. The outlet leak is still there. And 1 by 10 minus 1 by 8. I'm taking it to the other side. Okay, so over here, I'm taking its LCM like 40. So I just doing like 10 into 8. Okay, 10 into 8, that is 80. And I'm just taking like 80, 40. 40 will do. So 40. I'm just doing it like that. Okay, trial and error method in my mind itself I'm doing. So I'm just giving you all the techniques with me. Okay, minus 1 by 40. So 40 hours. Jayant, KJ. Okay, 40 hours is the right answer. Yeah, Nishwa, good. Nishwa and KJ given it right. 40 hours. Okay, good, good, good. Let's come to the next question. Two pipes, A and B, can fill a tank in 1 hour. Okay, so A can fill it in 1 hour, B can fill it in 75 minutes. Take it like that. Okay, and there is an outlet C. So if all the pipes are open together, tank will full in 50 minutes. Combined efficiency also you can find. And next is, how much time will be taken by C to empty it? Efficiency of C is asked. We have our basic equation. Everything is solvable in our basic equation. Okay, so A, B, and C's combined efficiency. Just find that and solve it. That's enough. So 1 hour, convert it into minutes. Okay, actually this particular thing is given in minute, this is given in minute. Convert it into minute and do it. Okay, these kinds of conversions are very much important. So it is 1 by 60, 1 by 75. We don't know about C. Keep it like C itself. And it is 1 by 50. If you solve for C's efficiency, you are getting the answer. So what will be the LCM here? Difficult. Little bit difficult. Go for 300. I'm sorry. I'm just talking about 300. I will write 300. Okay. Go for 300. That will do better. Go for 300. So denominator will be 300. I think 150 will not doing that. That is why I just took 300. So 6 into 50, 300. 4 into 75, 300. 5 into 60, 300. Okay. 6 minus 9 minus 3 by 300. Now I think you guys got the answer. Minus 1 by 100. Invert, you are getting 100 minutes. Okay. So we are getting into the next chapter. Before that, let me conclude for this particular chapters, 2 chapters. We just discussed 2 chapters, that is up to here, and by the next 1 hour we'll be discussing about another type of questions like speed, distance, time, train, bot and stream. That is what we are going to discuss in the next 1 hour. So this 1 hour, we just discussed 2 chapters, work time and pipes and cistern. Both chapters, we are doing questions in the same way. Now let's get into the next chapter. Speed, distance, time. Speed, distance, time. So we have few equations over here. So I will give you the base equation. Okay. So over here, speed equal to distance by time. Okay. Or this chapter is STD. Okay. This chapter is STD. Speed into time equal to distance. Okay. Earlier at persons at distant places. Okay. We used to call STDs. Okay. So speed into time equal to distance. Okay. Is the KJ is asked a question. Is this the same topic studied in the school? Obviously, yes. Up to 10th, we learned these things. Okay. Now we are learning it in a competitive exam perspective. Okay. We learned it in school in a like a exam perspective, but now we are learning it in a competitive exam perspective with some added things. Okay. KJ. So I'm just getting into this chapter. So, but it will not be exactly like what we learned in the school, because we may not be learned it in a competitive exam perspective at the school. So the perspective changes you can notice over here. And you don't need to blame yourself for not remembering many of the things which we are discussing over here at the school, because it's a hard, because I think we had learned it 2 years back, or from 5th to 10th we learned a lot, but we are just revisiting them in a different perspective. Okay. So speed into time, that is distance. So we are discussing about average speed in this chapter. KJ. Okay. Average speed. So total distance by total time. This is the change which is going to happen here. So total distance, say the distance are d1, d2, d3, and etc. up to dn, and the total time. Actually, we only have this equation. We are just connecting these two other equations by the total time, t1 plus t2 plus t3 plus etc. up to tn. We can use small t's, that will be better, plus tn. Okay. And that is the equation for speed average, the base equation. 2 more equations you guys need to remember. Not need to remember, you need to connect. Okay. You need to connect to this. This is the thing in your mind. You just connect this equation with this. After that, speed equal to distance by time. That is what we are having. So over here, instead of distance, we are going to substitute speed into time. Okay. So speed average becomes, distance becomes speed 1 into time 1 plus speed 2 into time 2, etc. up to speed n into time n divided by t1 plus t2 plus etc. up to tn. Okay. This is one substitution. So next is for substituting for time. Time equal to distance by speed. So speed average will be having new equation, that is like d1 plus d2 plus d1 plus d2 plus d3 plus etc. up to dn divided by time. Time, that is like d1 by s1 plus d2 by s2 plus etc. up to dn by Sn and so on. So this is the first equation, this is the second equation, and this is the third equation, and this is the base equation. This is the mother of these equations. So keep these equations in mind for solving questions. Depends upon the availability of the things. If the question is provided distance and time, go for the first. If the question is providing speed and time, go for the second. If the question is providing distance and speed, go for the third. That's it. So let's try one question. If you guys want, you can take a screenshot and your question comes here. A car moves 300 kilometer at a speed of 45 kilometer per hour. Speed is there, distance is there. So keep in mind which equation we are going to use. Then it increases its speed to 60 kilometer per hour to travel another 500 kilometer. Find the average speed of the car. Okay, so just solve this question. I'll give you the equations. So we want average speed. Okay, so over here, distance is here, d1 plus d2. Is the time is provided? No, speed is provided. So d1 by s1 plus d2 by s2. Since we only have 2, we are just using 2 over here. Okay, this is the equation we are going to use. So it will be like average speed. 300 plus 500 divided by, this is how the average speed in our vehicle is also calculated. Okay, so over here 300 by 45 plus 500 by 45. Let's see, sorry, by 60. Let's see how you guys solve this question. Let's take 100 outside. Let's take 100 outside. 3 plus 5, simply 8. 100 outside, here 2. 3 by 45, it is 1 by 15. And 5 by 60, that is 1 by 12. Cancel these hundreds. Okay, never keep these zeros. Try your level best to avoid these zeros. Okay, it will take a lot of time if you keep them with you. Sorry. And even here you can cancel. This is 3 by 45. So when you cancel this, this become 1 by 15. This become 1 by 12. Okay. Yeah, thank you, KJ. It become 1 by 12. And it is like 8 divided by 1 by 15 plus 1 by 12. 1 by 15 plus 1 by 12. This is what we need to solve now. So 1 by 15 plus 1 by 12. Take the LCM 60, like this is 4, this is 5 by 60, that is 9 by 60. Okay, so it is 9 by 60, you can cut it. It is 3 by 20. Take it over here. 8 divided by 3 by 20. 20 will be going up. So it will be like 8 into 20 by 3. That is 160 by 3. Okay. So what is 160 by 3? Do it in mind. We know that 150 by 3 plus 9 by 3 plus 1 by 3. I just splitted 160 like 150 plus 9 plus 1. Okay. Divided by 3. So 150 by 3, 50. You can do it in mind. 9 by 3, 3. 1 by 3 is 1 by 3 itself. So 53 and 1 by 3. Okay. Actually, these things are for your mind calculation. How will you solve for 160 by 3? Simply do it in our familiar ways, like convert it into 150, 9, 1. So 53 and 1 by 3. So the right answer is 53.33 kilometer per hour. Okay. Let's try the next question. A covers 1 by 3rd of the journey at the speed of 10 kilometer per hour. Okay, so 2 more equations are required for solving these things that we will be discussing. Okay, anyway, you guys can do it with the available knowledge. So 1 by 3rd of the journey at the speed of 10 kilometer and half of the rest of the speed at 20 kilometer per hour and rest at the speed of 30 kilometer per hour. So actually, 1/3, that means a particular distance d, and half of the rest, that means 1/3 gone. 1 minus 1/3, that is 2/3. Half of 2/3, that is again 1/3. So the second step is also 1/3, and already 2/3 is done by 2 1/3. Then the remaining is also 1/3. That means the distance covered is same. So you can use the equation like d1 plus d2 plus d3 divided by d1 by s1 plus d2 by s2 plus d3 by s3. You can, in this question, you can find all the distances are same. D1 equal to D2 equal to D3 equal to D. Substitute D plus D plus T. D by S1, D by S2 plus D by S3. You can take D as common. Okay. The numerator become 3D, and denominator you can take D as common. So it will be like 1 by S1, 1 by S2, 1 by S3. So you can cancel these D's. Okay. That means the equation which we are going to use is 3 divided by 1 by S1 plus 1 by S2 plus 1 by S3. Vishal, you can use the number provided in the chat. Okay. So through just ask this through the WhatsApp, they will be replying it. Okay. Or else after this session, you can put it in the comment over here also. By that comment also, they will be, that means our people. Okay. Our people will be addressing your each and every doubt. Don't worry. So over here, speed average of the equation. We have the equation. Actually, as I mentioned earlier, in this question, the distance are equal. In this question, the distance are equal. How will you know that the distance are equal? Because like triangle, equilateral triangle, the things are here. Okay. So covers 1/3 of the journey at the speed of 10 km per hour. So 1/3 is done. So half of the rest, 1 minus 1/3, because 1/3 is over. That is 1/2 into 2/3. Okay. So again, 1/3 distance is we need to cover. After that, the remaining, that means 1 minus 2 1/3 are gone. Another 1/3 is the remaining. Okay. So this is the 3 distances. So the distance covered are equal. Every time it is 1/3. Every time it is 1/3. So the speed average becomes the same equation we are having here. 3 divided by 3 speeds. 1 by 10, 1 by 20, plus 1 by 30. Okay. So now if you solve for this, 1 by 10, I will be solving for 1 by 10 plus 1 by 20 plus 1 by 30. We will be taking an LCM of 60. That will be better. 6, 3, 2. That is 11 by 60. Okay. So it will be like 3 divided by 11 by 60. 60 to the top. That is like 180 by 11. Okay. 180 by 11. So 16 into 11, I think 176. Okay. So you can do it like 176 by 11 plus 4 by 11. So it will be like 16 and 4 by 11. This is for mind calculation. 16 and 4 by 11 is the right answer, or 16.43, 38, 33, 7. 16.36 kilometer per hour. Okay. 16.36 kilometer per hour. That will also do the answer. Sir, is there any important chapters for Nata exam? Important chapters. Actually, the sprint session will be covering those important chapters. And KJ, let's see that. I will make a session based on the first Nata, which is happening tomorrow. Okay, I'll be making a session for the topics of priority. Okay, soon we will make that. Anyway, for arithmetic, all the arithmetic topics like speed, time, work, like, and ratio and percentage is very much important. Okay, ratio and percentage and so on. There we'll be discussing those things in detail. So over here, this is the answer. And an addition, if there is 4 speeds, speed average, if there is only 2 speeds, then the equation will be like 2 divided by 1 by s1 plus 1 by s2. If the question we are having 4 speeds, then speed average, we will be using an equation like 4 divided by 1 by s1 plus 1 by s2 plus 1 by s3 plus 1 by s4. Okay, I'm not getting you complicated with the formulas. That is why just use your common sense. Okay, so average speed, if there is 2 speeds, if distance are equal, go for 2 divided by 1 by s1 plus 1 by s2. If there is 3 speeds, speed average, go for 3 divided by 1 by s1 plus 1 by s2 plus 1 by s3. If there is n speeds, go for speed average n divided by 1 by s1 plus 1 by s2 plus 1 by s3 plus etc. up to 1 by s1. Sorry, sn. So let's move to the next question. 2 speeds, 2 speed question. The equation is given 2 seconds back. Solve this. A man makes his upward journey at 16 km/h. In between, I will have some water. You guys just solve this question. When I'm solving these questions, you can have water. Okay. So we're having Nata tomorrow. Just put it in the chat. Let me know. Be confident. Okay. Be tension free. If the tension comes into being, we can't think properly. Be cool. We have few more attempts in our hand. Be cool. The coolest will be cracking these exams. Okay. Because through my students, I just found that those who were getting into tension of exams, losing their efficiency by 10%. Okay. So if you are attending these things with a cool mind, you will be getting 10% marks more. Okay, keep it in mind. So a man makes his upward journey at 16 km/h and downward journey at 28 km/h. What is the average speed? So speed average. So 2 divided by 1 by s1 plus 1 by s2. On rearranging this equation becomes, if you want, you can note this. It becomes 2s1 s2 divided by s1 plus s2. Okay, this equation will become like this if you are rearranging this. Like you can cross multiply s1 plus s2 divided by s1 s2, just coming at the top. Okay, 2s1 divided by 2s1 s2 divided by s1 plus s2. Okay, so over here in this question we can solve using this equation, speed average. So 2 into 28 into 16 divided by 28 plus 16. So 2 into 28 into 16 divided by 28 plus 16. That is 34, 44. So you can divide with the 4. So this is 7. This is 11. So is there anything going with the 11 here? So it will be like 14 into 16. 14 into 16 over here. By 11. So 14 into 16 by 11. So that is like 224. 14 into 16. 224 by 11. That is easy. Okay, because 20 into 11 is 220. So 20 and 4 by 11. And I had solved 4 by 11 earlier. So it is 20.36. Okay, 20.36 km/h. So that's it. Come to the next question. Next question is from bot and streams. Next question is from, can you repeat the formula, sir? Definitely KJ. KJ, this one. So over here, average speed. If the distances are same, we are using this equation d1 plus d2 because we have d1 by s1 plus d2 by s2 here the D1 equal to D2 equal to D. So D1 equal to D2 equal to D. So over here, D plus D divided by D by S1 plus D by S2. So it is 2D divided by, you can take D as common, 1 by S1 plus 1 by S2. So when the two speeds are given and distance are equal, you can use this formula. Okay, so 2 divided by 1 by S1 plus 1 by S2. And you can cross multiply this, like 2 divided by S1 plus S2 divided by S1, S2. Okay, just crossing. So S1, S2 will be coming to the numerator, 2 S1, S2. But up to there is not wanted. Up to here is fine. You can, if you want, you can keep this S1 plus S2. Okay, RKJ, fine, good. So let's move to the next area. RKJ, very happy to hear from you. Okay, so these kinds of active participation, that is what I am expecting. Otherwise, it will be going like a one-way traffic. It will be difficult for me also. Okay, because I'm a classroom teacher as well as I'm an online teacher, and if I'm getting proper responses, my efficiency will also increase. Your efficiencies will also increase. That will be what affects our class in a positive way. So that is why these kinds of active participations we are requiring. Okay, RKJ. Okay, so over here, we are going to discuss about the next topic, that is bots and streams. Just look into this basic diagram. Okay, assume this is a stream. Okay, this is a stream. A river is flowing. Okay, the river is having a speed. Okay, that is speed of stream. So S stands for speed of stream. So this is the single page which help you to solve every question from this chapter, speed of stream. And there is a boat going in this direction, that is speed of boat. Okay, so I'm just giving you an example. Stream speed is 2 meter per second, and boat speed is 3 meter per second. Okay, so these are the speeds with you. So what will be the speed of boat in upstream? Okay, speed of boat in upstream. What will be the speed of boat in upstream? Just put in the chat. The boat will try its level best to cross 3 meter. Okay, 3 meter he will try, but the stream will push him back. The stream will push him back by 2 meter. Okay, so 3 minus 2 will be the result. So here as an equation, speed of boat minus speed of stream. So when the boat tries to move in the upstream, that means against the flow of the river will push him back. Okay, so he is trying with the 3 meter, then it is pushing with the 2 meter per second, then the effective will be 1 meter per second. Keep this example in mind, not the equation. Keep this example in the mind, not the equation. Okay, if this example is with you, you can create the equation from that. Okay, by hearting the equations are difficult. By hearting the example is easy. So over here, speed in downstream, the boat is going in this direction with 3 meter per second. Then the boat will be getting a push from the stream. That is, speed of boat will be getting a push by speed of stream. That is 3 plus 2, it is getting a 5 meter per second speed. So two equations are ready for us for the boat and stream. This is the boat and stream basic equations. This is the boat and stream. Okay, and here the SB stands for speed of boat in still water. Then S up stand for speed upstream. And SD stands for speed downstream. Okay, you can note this equation. One more set of equations are there for finding speed of boat and speed of stream. For finding speed of boat, just add speed downstream plus speed upstream. Just simply add. So if you add speed downstream plus speed upstream, you can see that speed of stream and speed of stream will be get cancelled because negative and positive. Okay, so you will be getting 2 into speed of boat. Actually, you want only speed of boat, so divide by 2. So you will be getting speed of boat. Similarly, speed of stream, speed of downstream minus speed of upstream. At that time, speed of stream, that negative become positive. Okay, taking this negative. So you will be getting 2 speed of stream in the numerator. So divide with 2. So keep these equations in mind. This chapter is only these 2 equations. After this chapter, we will be discussing train related problems. How to solve questions from train through a single equation. You will be having a single equation to solve train related question. After discussing problems from this chapter, we are heading to that particular one. Now let's try this question. A man can row a boat in downstream at 12 km per hour and upstream at 8 km per hour. Find the speed of the boat that the man can row in still water. What are the things provided? Actually, these things you can see. Simply seeing the question, you can put the answer in the chat. That level of question is this. A man can row a boat. This is his speed boat downstream at 12 km per hour. Okay, this is speed downstream. This is speed upstream. What is the question? Speed of boat is the question. Speed of boat, that is downstream plus upstream by 2. In this question, 12 plus 8 by 2, 20 by 2, 10. You can simply do it in mind and put your answers in the in the computer. You can put your answers when it comes to Nata. Next is a boat running downstream covers a distance of 20 km in 2 hours, while it covers the same distance upstream in 5 hours. Okay, speed of the boat in still water. So everyone, like our videos for the future access also you will be getting by liking, and you can save the videos also, and you can just subscribe our channel and you can look into the playlist. Okay, in the playlist in the upcoming days we will be updating all the sprint videos there, so you can access to all the videos in a order. So over here, a boat running downstream covers a distance of 20 km in 2 hours. The same distance upstream in 5 hours. Then the speed of boat in still water is. Then the speed of boat in still water is. What is the speed of boat in still water? Solve this and put it in the chat. I'm waiting for your replies. Quick. So over here, a boat running at the downstream covers a distance 20 km in 2 hours. Speed downstream 20 kilometers in 2 hours, that is 10 km per hour is the speed, and it covers the same distance upstream, that is same distance means 20 km in 5 hours, that is upstream speed is, what is the upstream speed? That is instead of 10 here comes 20 by 5, that is 4 km per hour. Okay, 4 km per hour. Okay, so over here, the speed of the boat in still water. Speed of the boat in still water. So speed of boat being asked. So over here, downstream plus upstream by 2. That will do the answer. Okay, a boat running downstream covers a distance of 20 kilometers. That means 10 kilometers in an hour. And upstream, the distance are not changing. So it is 20 by 5, that is 4 km per hour. So you can substitute here 10 plus 4 by 2, that is 14 by 2, it is 7 km per hour. Option A is the right answer. Very good. So let's move on to the next question. A man can swim 3 km per hour in still water. If the velocity of the stream is 2 kilometers per hour, so a man can swim. So consider like speed of man. Speed of man, it is apparently equal to speed of boat in our equation. So speed of man is 3 kilometers per hour. In still water, if the velocity of the stream, speed of stream is given 2 kilometers per hour. The time taken by him to swim to a place 10 kilometers upstream and back. Okay, what we want? We want time for upstream and time for downstream. That is the combined time we want. Okay, so for time up, we will be going for, so speed equal to distance by time. So time equal to distance by speed. So for that, distance by speed upward plus distance by speed downward equal to total time t. So now let's look into the things provided over here. So speed of man and speed of stream is given. So his speed of upstream will be like 3 minus 2, that is 1. And his speed downstream is given, that is 3 plus 2, that is 5. Now the distance. The time taken by him to swim to a place 10 kilometers upstream. That means the distance are same. So 10 kilometers up. So 10 by speed up, that is 1, plus downstream. Downstream is also 10 kilometers, but the speed is little bit high. So it will be like 10 plus 2, 12. Anybody? So try to put your answers in the chat. 12. Let's move to the next question. A boat goes 6 kilometers an hour in still water, but takes thrice as much time in going the same distance against the current. Okay, so the speed of the current in kilometer per hour. A tricky question is coming finally. Okay, a tricky question is here. A boat goes 6 kilometers an hour in still water. Speed of boat 6 kilometers per hour. Takes thrice as much time. So time up versus time down. Okay, you are a few seconds back. Okay, come to the live position. So time up equal to time down in what way? So time up is 3 times time down. That is given in the question. Okay, time up is equal to 3 times, which is taking to going down. That is given it like, but takes thrice as much as time in going the same distance against the current. That is what I just mentioned here. So going up will be taking a lot of time, and here it is 3 times going down, because we can go in the downstream in a very quicker manner. So that's it. So the speed of the current is being asked. So speed of current. So with this relation, how will you solve this? A boat goes 6 kilometers an hour in still water, but takes thrice as much as time. So all the data in the question I had listed here, you guys can put your responses in the chat. I will look into them. So here in this question, demand of the question, speed of stream. Okay, so over here, speed up equal to speed of boat minus speed of stream. Unknown. Speed of boat is 6 only. 6 minus speed of stream. That is speed up. Similarly, speed down you can find like speed of boat plus speed of stream. That is 6 plus speed of stream. So a boat goes 6 kilometers an hour in still water. So we got 2 equations. So T up, that means the distance are same. So D divided by speed up, and 3 into D divided by speed down, because we are already seen that speed equal to distance by time, time equal to distance by speed. That is what we had recorded here like this. So the distance and distance you can cancel, and speed downward equal to 3 into speed upward. You can equate in this way. So speed downward, that is 6 plus speed of stream. That is equal to 3 into 6 minus speed of stream. Okay, so downstream speed is higher. So over here, 6 plus speed of stream equals 18 minus 3 into speed of stream. So just take the speed of stream to the left, 3 speed of stream. So it will be like 4 into speed of stream, that is equal to 18 minus 6, that is 12. That is 4 into speed of stream. So speed of stream, that is equal to 12 by 4, that is 3 kilometer per hour. Okay, so the speed of stream is asked, and option C. I'm sorry, option C. Okay, that is 3 kilometer per hour. So let's try another question. A man can row at 5 kilometer per hour in still water if the velocity of the current is 1 kilometer per hour, and it takes him 1 hour to row to a place and come back. So T up plus T down is 1 hour. How far is the place? Okay, that is a question. How far is the place? So a man can row a boat. So you can solve and put it in the chat. A man can row at 5 kilometer per hour in still water. So speed of boat. Okay, so speed of boat, a man can row 5 kilometer per hour, and speed of stream 1 kilometer per hour. Upstream, that is 5 minus 1, that is 4 kilometer per hour. Downstream, that is 5 plus 1, that is 6 kilometer per hour. All the data we are having now. So we want to find the distance. Actually, T up, we have the equation T up plus T down. These are the things we are making ourselves. Okay, that is equal to 1 hour. So T up means distance. So upward distance will be same. So 1 hour to row to a place, that is D. D divided by speed up plus D divided by speed down equal to 1. So this is the things which is we are getting from the question. So now we will be substituting for the speed upward, that is 4. Speed downward, that is 6. It is equal to 1. Just solve for D. Let's take D common. 1 by 4 plus 1 by 6 equal to 1. So 1 by 4 plus 1 by 6. So it is D. So over here you can cross it like 6 plus 4 by 6 into 4. Now you guys can smell the answer from the options. Okay, equal to 1. So the things over here, distance equal to 6 into 4, that is 24, divided by 6 plus 4, that is 10. I just take this to the other side. So 6 into 4, 24 to the numerator, and 6 plus 4 coming to the denominator. That is 2.4 kilometer. Okay, 2.4 kilometer. Option C. Option C is your answer. Let's try the next chapter. Okay, so the next chapter is train related problems. How to solve questions. One-stop solution I'll be giving. Okay, so over here, we can start from assessing some basic ideas. So over here, let me construct a railway track, a platform. So you guys can find a platform here, a railway platform I'm just constructing. So this is my railway platform. Okay, so say this is, I'm just giving you a practical example to keep it in mind. So this is 500 meter long. Okay, a small platform. Okay, it's in a certain country having small trains. 500 meter platform, and into that platform, my train is coming, and my train is 200 meter long or 300 meter long. Okay, my 300 meter long train is coming here. Okay, this is my 300 meter long train. So this is my train. My train is approaching the platform. So my first question, how much distance this train need to travel to completely get into the platform? 300 meter. 300 meter, the train needs to travel. The train needs to travel 300 meter to completely get into the platform. After that, another 200 meter to reach the corner. Okay, the engine. The engine need to reach the other end of the platform. It has to travel. The engine has to travel 500 meter. I think it's clear. Okay. From there, my train need to travel further. My train need to travel further. How much? The engine reached the platform end now, but the train is inside the platform. So the train need to come out of the station. So the engine needs to travel entire length of the train once again. So for the train need to be completely out of the platform, then it has to travel this 500 plus 300. This is the length of platform. This is the length of train. Okay. So the trains needs to cover length of platform as well as length of train to completely come out of the railway station. That is the basic thing you need to keep in mind while solving this question. So we have the basic equation. Speed equal to distance by time, or speed into time equal to distance. Based on this equation, all the train related problems are revolving. All the train related problems are revolving around this equation. Okay, all the train related problems are revolving around this particular equation. So speed into time equal to distance. So over here, what is the change in speed for this chapter? Speed is relative speed. What is time? Time itself. Distance, total distance. Okay, so that is a change which is happening in this question. I'm just level by level elevating you to this chapter. Okay, not suddenly getting into the chapter. I'm just level by level taking you to the chapter. So I will give you what is a relative speed now. So a relative speed. What is relative speed? So if there are two trains, or one train and another, like consider like an object. Okay, so ST stands for speed of train, and SO stands for speed of object. Object can anything, like a man running against a train, a car running against a train running against a train, anything be there. So relative speed is like speed of train plus speed of object when if the object and train are traveling in opposite directions. That means if they are traveling like this is speed of train and this is the object, speed of object. If they are traveling in opposite direction, add it. And you can take a practical example. When you are traveling in a car or a train, you can find that when you are traveling at 40 km per hour and another vehicle is coming against you at 30 km per hour, and you felt that that particular vehicle is traveling at 70 km per hour. Somehow you will be the fastest one, even though you felt that he is traveling in a more speed than you. And that is why in matter of seconds, the vehicles are crossing each other. Okay. Similarly, you can find it in trains also. And parallel running of the train. If you are parallelly running, that means in same direction, you will be feeling that nobody is moving. KJ. Okay, you'll be feeling that nobody is moving. So speed of train minus speed of object. Okay, so take the difference. That means if you are traveling at 20 km per hour and the other train is also traveling at 20 km per hour, 20 minus 20, you will be feeling that you are the both of the trains are still, and you can observe a passenger on the other train constantly. Okay, he will be not moving. So coming over here, you can substitute relative speed. I'm just using that plus and minus together. So speed of train plus or minus speed of object. You can use that plus or minus depending upon opposite side or same side. into time. Total distance. So this is a platform, length of platform. That is, you can take like length of object. Okay. So total length traveled. So the train has to travel entire length of an object plus length of the train. Also, the train need to travel to cross that object. That is the total distance. If you know this equation, this chapter is over. If you are good at this equation, this chapter is over. Okay, then some special cases. Speed of train, there will be always a speed given. Speed of object can be 0. When then the objects are stationary, it will be 0. And stationary objects like lamp post. Okay, lamp post and like platform, bridge, etc. Because whenever a train is coming, bridge will not run away from there. Bridge will be there. Okay, those things will be having speed 0. Then speed of object will be a finite number. When it will be another train, another moving train, moving car, moving person, anything that is moving will be having a speed. So next is length of object, special cases. Length of object is also having 2 special cases. Length of object will be 0. When it is a lamppost, everything is 0 for him. Because comparing to the length of the train, lamppost is negligible. That is why we are treating it like 0. Okay, lamppost is 0. A person. Okay, if you are taking the case of a person, you're taking the case of a person, then also 0. So negligible width, anything is having negligible width, consider it like 0. But it will be a finite number. When it will be a finite number? It will be a finite number when it is a platform. Another train. Okay, another train or bridge, tunnel. Every time there will be a finite number. So you guys can scan all these things in your mind, because the train related problem chapter, this is the final set of equations, nothing else. So I'm just slowly elevated you from this equation. This is in your mind. Okay, connect this equation to this, so it will be remaining in your mind. So this is the final. So learn like this. Don't by heart this. Learn this. It is a process. Learning is a process. Understand the process and learn it in that way. Then you will be starting enjoying these things. Unless we will be saying, maths is boring. I'm not going to solve anything in maths. I'm not capable of solving maths questions. These things are our mere thoughts. If you enjoy this process, everything will be easy. And this is not a single day process. You will be taking a little bit time to learn the process. But you definitely learn and you will start enjoying, because a lot of courses or a lot of things you need to learn in your upcoming days or years. Okay, so learn the process of learning. Okay, for that you just try to learn how the learning is a process. So learn that process first, then start learning. So here is your question and you can read it. So don't forget about our online batch which is starting. So in our online batch you will be getting a personalized coordinator who is coordinating all those things and mentoring you to how to succeed in these kinds of exams. And through that coordinators, you can directly contact us, like regarding your doubts and everything. And we will be taking online sessions. So for that, just join our April 8 batch. And for that, you can use the phone number in the chats. And even in my PPT, somewhere we'll be showing that things also. And all your queries related to exams also, you can use that number to ask. So I'll be getting into the answer of this question. I don't know how to solve this question blindly. I'm just putting the equation. Speed of train plus or minus speed of object into time equal to length of train plus length of object. I will look for what I was provided in this equation. when a train comes. When a train comes, I will take my suitcase. This is my suitcase, or this is in my suitcase. Okay, whenever train comes, I will take my suitcase or bag. So this is in my bag, and I will check for what the train is here to provide, or what are the things mentioned in the train is in my bag. So a train 300-meter long. Length of train is given. Good. He's running at a speed of 25 meter per second. Speed of train is there. Okay, 25 meter per second. Okay, I'm just demystifying the question. It will cross a bridge of 200 meter. So bridge, length of object. Bridge is having a length 200. Bridge will be having 0 speed. Okay, so this is the data provided in the question. Okay, plus or minus is not important here because speed of object is 0. Okay, and that bridge will not make an issue with the minus or plus. So now you can rewrite if you want. I usually won't rewrite, but this instant I'm rewriting it. So you can rewrite speed of time, train into time. Speed of train into time will be equal to length of train plus length of object. Actually, we can make 6 to 12 equations based on this particular day things based on this special case. But I had summarized everything. Okay, so over here, 25 into t. We don't know the value of t. I think the question is for finding t. So length of train plus length of object, 300 plus 200. So 25t equals 500. T is equal to 500 by 25. Simply 20. Am I right? 25. So over here, this is 20. Okay. Okay, it is 20. So yeah, just miss. So 20 is the right answer. Let's move to the next question. A train is moving at a speed of 132 km per hour. If the length of the train is 110 meter, how long will it take to cross a railway platform of 165 meter long? Okay, a train is moving at a speed of 132 km per hour. 132 km per hour, the other things are in meter. So we need to convert this into meter per second. So kilometer per hour need to be converted to meter per second. So kilometer means 1000 meter. Hour means 60 minutes, 60 seconds. Okay, so how will you convert? 10 by 18. Sorry, 10 by 36. 5 by 18. Okay, that is meter per second. 1 kilometer per hour. Okay, so 132 kilometer per hour. 132 into 5 by 18. Okay, 132 into 5 by 18. So just convert this. So you can cancel this. So it will become 6. You can cancel with 3. So this will become 44 for 44 divided by 6 here. And over here, you can cancel this once again. This is by 2 you can cancel. This is 22. This is 3. So this become 110 by 3. Okay. So the speed will become 110 by 3. So 110 by 3. So I will be keeping that speed like that. Okay. 110 by 3. So over here, a train is moving at a speed of 132 km per hour. So keep these calculations aside. So equation, speed of train plus speed of object plus or minus into time, that is equal to length of train plus length of object. Okay, so speed of train is being given, that is 132, and speed of object. So a train is moving at a speed of 130. How long will it take to cross railway platform? Speed of object 0. Okay, into 5 by 18. I will be taking that 5 by 18. Conversions we can do at the later. Or 110 by 3 you can take directly. Into time. Okay, equal to length of train plus length of object. Length of train 110, length of platform 165. So over here, 132 into time, that is equal to 110 plus 165, that is 275 into 18 by 5. So time equal to 275 into 18 divided by 132 into 5. So you can now cancel 5, 275. 5 over here, I will be cancelling it over here. That will be better. I want more space. 275 into 18 divided by 132 into 5. So this is 5 into 5, 25, 55. And over here, 130. So you can divide it with 18. That is, you will be getting 6 here. And you will be getting 4 here. We just divided by 3. And now you can cancel for 11. So this is 5. This is 4. So 5 into 6, that is 30. 30 by 4 is the answer. 30 by 4 is 7.5. Option B. Okay, option B. So directly converting at the beginning, I think not that much good. You can keep that conversions up to the end because sometimes you can easily cancel these things. So let's move to the next question. You can try this one. Two trains, 137 meter and 163 meter in length are running towards each other on parallel lines. One at the rate of 42 km per hour and another at the rate of 48 km per hour. In what time will they be clear of each other from the moment they met? They are meeting, they need to cross each other, and the train will be moving in two directions. So here also we don't know the things. So we will be simply looking into speed of train plus or minus speed of object into time, that is equal to length of train plus length of object. Everything is given in meters. So we need to convert the speed, but I will be doing it at the end. So the speed of train, 42, use another color, 42, speed of object, 48, time unknown. Okay, this is kilometer per hour. Okay, keep it in mind, kilometer per hour. Length of train, 137, 137, 160. Another train, 163. So 42, traveling in opposite direction, take the plus. Plus 48, you are getting a 90. Okay, multiply with the 5 by 18. Okay, doing individual conversions will be difficult because here you are getting 90. You can easily cancel. Into time, 5 by 18 is for converting kilometer per hour. Okay, so into time, that is equal to 137 plus 163. Okay, so at the end, it is 300. So 90 into 5 by 18 into time equal to 300. Cancel this. This is 5 and 5 into 5. So T is equal to 300 by 25. So now just solve for this. You will be getting like 12. Okay, you are getting time equal to 12 seconds. So one-stop solution. Single equation, you can solve all these questions. Okay, so today we just learned the chapters. I'm just giving you a summary. Today we had gone, those who joined at the end of the live, you can refer the videos once the recording is available. So we just look into the chapter work and time. Then we look into pipes and cistern. Okay, these two chapters are connected in efficiency terms. These two chapters are doing in efficiency term. And then let's look into the next set of topics like speed, distance, time. Okay, next we look into bot and streams. Okay, so I tried to get you 5 questions from today. Okay, so if you are good at the topics which we had learned today, you'll be getting 5 marks for 5 questions. So bot and streams. Then the final we look into train related problems. Okay, train related problems. So in the upcoming days, I'll be coming with another set of topics in the sprint. So by this month, okay, we have the exam for the 3 months. By this month, we will be getting a clarity about what are the topics asked in the exams, and based on that, we will be continuing our videos and your request priorities in the chat also. Okay, KJ. So I'll be handing over to my next faculty. So they will be taking drawing. I think the faculty will be ready in a couple of seconds. So you guys can, if anyone can have any doubts, we can put it in the chat. Me as well as our people will be addressing those doubts over here. So 1 second, I'll be stop sharing over here. I hope you guys noted the numbers which is provided in the chat. So Nishida ma'am will be joining from here onwards. So Nishida ma'am, are you there? So she will be taking you to the drawing session. After that, you'll be having ARC awareness session. So Nishida ma'am.
Hello.
Ma'am, you can take from here onwards. The students are all yours. Okay, ma'am will be joining in a second. So is the hall tickets are ready? Is the hall tickets are ready with you guys? Huh? Did you look into your hall tickets? Because it's very much important to look into the hall tickets to know. It's not regarding knowing where the examination is happening, to check whether there is any mistakes or anything. And by tomorrow, just be tension free. Okay, don't have any kind of tensions in your mind. Okay, don't have any kind of tension by tomorrow, because if you have anything, please wind up those tensions by today, and you can refer to the things which you had already learned. Don't try to learn anything new. Only just focus on the things which you had already learned, especially looking into the equations. Okay, equations, like all the collection of equations you will be having, like formulas and everything. Just go through a quick look into those things. Okay, so if you can't remember anything on a certain thing, just try to just try to visit them, but don't get demotivated that at the end of the day I'm not able to remember these things. Okay, so be confident. Wish you all the very best, guys. And our Nishida ma'am is with us. Ma'am, you can take from here onwards.
Hello, good evening. I hope I'm audible.
Yes, ma'am, you are.
Okay.
You can go ahead.
Thank you. That was a great session by you.
Yeah, welcome. Bye.
Hello, everyone. I am architect Nishtha Joshi. I'm a conservation architect. I work with heritage monuments and structures towards restoring and conserving them. And I'm also a faculty of architectural awareness at THiNC Institute of Design. Today, we are having these sprint sessions with you all, where we are discussing about various topics that are very important parts of the syllabus of Nata. So, in this session, we'll be talking about architectural awareness. And today, I've curated some questions for you to be discussed in this session, which have come in the previous years of your Nata exam. These questions are from 2021 to 23. these 3 years, the questions that have come in the exam, I've picked up some important questions, and today we'll be discussing those questions. We'll also be solving your doubts and queries. The live chat section is open for you all. You can ask me your doubts or queries through the comment section. And in between, whenever I get some time, I'll try to clear your doubts. So let me just share my screen. So as I told you that all these questions are from different years, different question papers. I've tried to incorporate different types of questions that come in the exam so that you get an idea of various topics as well as various patterns of questions that come in the exam. So this is the first question that I wanted to discuss with you all. This is a very common type of question that comes in Nata. These questions are visual based. There is some image that pops up on your screen. And by looking at that image, you have to do your analysis and answer the question that is asked before. This question is specifically related to principles or elements of design. It is a very important topic in Nata syllabus. Here you have to look at this image and you have to answer the 4 most appropriate principles or elements of design which are commonly observed. Now, the catch in these type of questions is that one or more answers can be correct. It is already asked in the question that you have to choose 4 most appropriate options, and there is a great possibility that out of the many options that are given to you, more than 4 can also be correct. But you will only be awarded the marks for this if you answer all the 4 correctly. Even if one of your selections is wrong, then you won't get any marks for this. But if more than 4 options are correct out of the given options, then you can choose any 4 of them and you'll still get the full marks. So look at this image. A composition is given on your screen. It has a green background and many triangles are there. These triangles are of different colors. They're of different intensities and even the line weight is different. Some of these triangles are they have a very thick border. Some of them are thin. This tells us a lot about this composition and this design, and many principles can be observed here. I hope you all have seen this picture nicely by now. Now, these are the options that are given with this question. Option A is contemporary colors, option B is datum, then symmetry, intersections, line weight, rhythm, hierarchy, asymmetry, and repetition. These are various principles of design. We have discussed these principles of design in our previous classes in great depth. So I'm assuming that you know the meaning of each of these terms. I'll still give you a short brief of each of them. Complementary colors is a type of color group or color combination where 2 colors are taken which are opposite to each other in the color wheel. Datum is also a principle of design. Then we have symmetry. Symmetry is a phenomena, a principle of design where when you divide an image through an imaginary axis, the left-hand side and the right-hand side of that image or composition are mirror images of each other. Then intersections. Intersection means intersecting lines or shapes where you can clearly see that 2 or different shapes or objects are intersecting each other at different angles. Line weight means thickness of a line. When we say line weight is more, we mean that the line thickness is more. When we say the line weight is less, we mean that line thickness is less. Then rhythm is another principle of design which is related to movement and rhythmic patterns. Hierarchy is another principle of design that talks about sequence. Then there's asymmetry, the exact opposite of symmetry. When there's asymmetry, then it means that if you're dividing and dividing a composition through an imaginary line, it won't be a mirror image. Both the sides won't be mirror images of each other. And last one is repetition. Repetition means one or more objects, patterns, or design are repeating in the composition. Now let's look at the image again. Now you know all the options that are given with this question, and you can see the elements that are there in this image. So by this, you can answer this question. As I told you, there is a great possibility that more than four options can be correct for such a question. So in this one, we have five right answers: A, D, E, H, and I. So A, complementary colors, is correct because you can see different pairs of complementary colors in this given image. Then second one is D, which is intersections. You can see many intersecting triangles in this composition. E is line weight, as I mentioned earlier as well. The outlines of these triangles, they all have different line weights. Some of them are very thick, some are medium, and some are thin. Then H, that is asymmetry, that is correct because in no possible way this composition is symmetrical, hence asymmetry is there. And I, repetition, because you can see repetitive shape and a repetitive pattern that is going on in this entire composition. So I hope this was clear. If you have any doubt related to this, you can ask your doubts in the comment section. Now, this is another question of the similar type. Here also, a composition has been given. By looking at this composition, you have to tell me what are the correct principles or elements of design that are associated with this one. Again, more than four options can also be correct. Please select mindfully and tell me what the right answer is. So I hope you have seen the image carefully now. It is a black and white composition. You can see black spiraling lines that are all going to one point. It looks like everything is merging at one central point. It's black and white, and major portion, the background of this image is white in color, and the spiraling lines that are going towards one focal point, they are in black. The options that are given with this question are contrast, pattern, rhythm, intersection, progression, static, shape, depth, and order. Now, let me explain all of these terms quickly. Contrast is when we use different, very opposing colors, like black and white color is a contrasting color combination. Then next is pattern. Pattern means a design which repeats itself by using two or three or maybe more design elements, we create a pattern, and these patterns can be often seen repeating in fabrics, in railings of a house. Railings are there in balcony, in the staircase. We can see patterns being created there, or in different areas, in different things, in your couches, in your curtains, you can see different patterns forming. Then again, next one is rhythm. We just discussed rhythm in the previous question. Intersection is there. Intersection means when lines or shapes or angles are intersecting. Then progression. Progression is actually very interesting. Progression means the process of progressing, moving forward. So if you feel like one or more lines or shapes are moving ahead, then you can see progression, the principle of progression in any composition. Then F is static. Static means stationary, stagnant, sticking to one point and not moving. So progression and static are opposite of each other. Then next one is shape. If you can see the use of any basic shapes, then you can say that shape is one of the important elements here. Shape is an element of design. It's not a principle of design. On the other hand, progression, rhythm, pattern, all of these are principles of design. Then next one is depth. Depth means the quality of being deep. This can be actual depth, like it is there in a well or in a river or a pond. It can also be visual depth, where we feel like the composition is showing something that is going deeper. And last one is order. Order is also something that is related to hierarchy only, one after the other, or one thing being more than the other. So we have five correct options in this one as well. A, C, E, G, and H. A, which is contrast. I told you in the beginning itself that black and white are contrasting colors. So that will be correct. Then C, rhythm. Rhythm is a principle of design where we can see movement, where we feel like the composition or the painting is moving. So in this composition, we can see some movement is happening towards the center, which is the focal point. So in this composition, we can see some movement. Hence, rhythm is one of the major principles of design here. So C, rhythm will be correct. Then next correct answer will be E, that is progression. Again, because we are seeing some progress, some movement. The lines are starting from somewhere and progressing towards a point. So E, progression will be correct. Then next one is G, that is shape. So do we see some basic shapes being formed here? Yes, of course. The background, it is rectangular in shape. You can see four rectangular panels are there showing us a basic shape that is rectangle. And last one is H, that is depth. When the lines are forming this radial pattern, they are progressing towards a center, hence creating a sense of depth, showing some deepness. So I hope that was clear. If you have any doubt related to this question or any of the principles or elements of design that I mentioned in the options here, you can ask your question in the comment section. I'm constantly looking at the comment section. It is open for us to interact. If you have any queries, you can ask me through that channel. And in between, whenever I get some time, I'll pause and I'll solve your queries. Even if you have doubts related to a similar kind of question that you have studied before, then also you can ask me those questions. Now, this is the next question, a very interesting one, a direct kind of a question. You can see that this is the image of Jantar Mantar. The given image shows the Jantar Mantar at Jaipur. What is the purpose of these structures? Now, I want you all to answer this question in the chat, in the comment section. Is it a rainwater harvesting system or mechanism? B, is it an astronomical observatory? C, is it a children's play area? Is it a garden? Or D, is it a solar energy generation plant? What is the purpose of the structures of Jantar Mantar? I'm waiting for your responses. Jantar Mantar, there are two popular locations for Jantar Mantar actually. You know that one very famous Jantar Mantar is also in New Delhi. So please don't get confused when in the exam Jantar Mantar New Delhi is asked. Both of the Jantar Mantars, either it is in Jaipur or New Delhi, they are option B, astronomical observatories. The purpose is astronomical observation. We'll go to the next question now. Okay, this is a very interesting question. Here, a color wheel has been given on your screen. In the depicted color wheel, which of the following quadrants have the wrong color sequence? Here, the entire color wheel has been divided into four quadrants. Four different quadrants can be seen. And you have to tell me that um, which out of these four quadrants is in the wrong sequence. You can see there are some warm colors in quadrant one. You can see orange and yellow and yellow green. And in quadrant two, again, some warm colors are there, red, orange, and orange yellow. Then you can see in quadrant three, purple and blue purple. Um, in quadrant 4, some cool colors are there, shades of blue and one green. So you have to tell me which is the wrong sequence. What can be the correct answer to 3? I can see one answer in the comment section. Someone is saying that quadrant 3 is the answer to this question, meaning quadrant 3 is in the wrong color sequence. So can you tell me what will be the right color sequence? What will be the right color sequence if quadrant 3 is wrong? Quadrant 3, that is option C, is the correct answer. Here the right sequence will be that this red purple should be on top and purple should be in the second number in sequence. So these two colors will interchange. Then it will be in the right sequence. So correct answer here will be option C, that is quadrant 3. This is the next question. Again, this is related to color theory. In this image, some color combination has been used. Here you have to tell me whether like which of the color combinations are used in this particular room in coloring the spaces in this room. You can see some color in the walls, the flooring of this room. Looking at this image, look at this color combination and tell me which color combination has been used. Your four options are complementary, analogous, triadic, or monochrome. So can you answer in the comments which color has been used? Which color combination has been used? You know the answer to this. We have already discussed this in great depth in our class. The right answer to this is B, analogous. Here, analogous color scheme has been used. Analogous color scheme is a color scheme which has three colors. It is a triadic color scheme. It has three colors in it, and these three colors are adjacent to each other in the color wheel. Adjacent means they are right next to each other in the color wheel. So as you can see here, three adjacent colors of the color wheel have been used in this portion of the wall, the background wall, and the flooring. So the right answer will be analogous color combination. Again, the next question. Here, a image has been given to you. This is the image of a terminal. And by looking at this image, you have to identify the four most important visual principles or elements in the given black and white photograph. Marks will be awarded only if all the answers are right. So I'm again reminding you, in such questions, 6 to 7 options are given, and in those more than four can also be correct. So please don't get confused. If you answer any four correctly, you will get the full marks. So please look at this. Here also you can see some focal point is being created. This is the focal point where all the lines are meeting in this focal point. It's black and white, so you can see contrast. What are the other principles that you can observe here? Please look at this carefully. I'm showing you the options now. So these are the different options. First one is distortion. Distortion means something which is being distorted, visually distorted, meaning it is not in the uh, correct size, or not all the ends or all the sides are of the same size. Then asymmetry. Asymmetry is the opposite of symmetry, meaning when you will draw axis to the center of any photograph or composition, it will not be, the two parts will not be the mirror images of each other. Then C is focal point. Focal point means a convergent point to which all the lines of a particular image, photograph, or drawing are meeting. Then D is grid. Grid means a checkered formation, a grid being formed. So can you see a grid is being formed in the ceiling here? Do you see this grid being formed? You can see some boxes are there and a grid has been created on the ceiling. Then convergence. Convergence is the act of converging or meeting at one point. Converging means all the lines meeting or gathering at one point. Then F is pattern. Pattern, again repetitive design. Then G is repetition. Repetition means repeating, coming one after the other and coming multiple times. H is parallelism. Parallelism is actually the act of having parallel lines, when multiple parallel lines are there in a composition. Then H, parallelism, will be correct. And I is fluidity. Fluidity means something which is non-stagnant. It is not stick to one part, or the lines are not just straight, the lines are curved, they look like they're flowing. Like the previous composition that we saw, where the black and white lines were then they were forming a spiral. That was a fluid composition. So I'm showing you the image again. Look at this and tell me which are the principles that you think are a part of this composition. So there are 6 correct answers. C, D, E, F, G, H. C is focal point. We can see a clear focal point being created at this point of the composition of this photograph, where all the lines are converging. Then the next correct answer is D. D is grid. A grid has been formed in the ceiling. Then E is convergence. All the lines in this composition are converging to the focal point. So E convergence will also be correct. Then next one is F pattern. A pattern has been created because of the boxes that were created through the grid in the ceiling. Some pattern or some design has been created which is repeating itself. So F pattern will also be correct. Then G repetition will be correct because you can see repetition of lines, the boxes, the elements, etc. Then H, parallelism will also be correct because we can see multiple parallel lines, be it in the floor or be it in the ceiling. Parallel lines are there, hence H parallelism will be correct. Are there any doubts related to this? I know a lot of these terms are new. We've discussed most of it in the class, but if you are attending our session for the first time, maybe these terms might sound very new to you. I still tried my best to explain it in a short manner, but if you have any doubts, you can ask me in the comments. Next question. This is one of my favorite types of questions. It's very interesting because to solve such questions is quite fun as well. They can seem confusing in the beginning, but these are actually the simplest kind of questions. These are match the following kind of questions. You have to match the faith in the left hand side, which is associated with the listed monuments on the right hand side. So some faith or religions or beliefs are given in the left side, and you have to tell me which is the monument that is related to this faith. In the left side, you have Baha'i, Buddhism, C is none, meaning no faith or atheism, and D is Sikhism. So the monuments are Ashok Pillar, Sri Harmandir Sahib, Lotus Temple, and Maitri Mandir. So can you tell me which are the monuments which are associated with which religions on the left? Okay, so in the comments, I can see C and R. C, which is none, is associated with R Lotus Temple. That's not the correct combination. Lotus Temple is associated with some faith. Any other answers? Let's match. In such questions, we always match the terms that we are very sure of. So think about the one monument that you know about, that you have visited or you've heard about it, you've seen it, or you're sure that this monument or this structure belongs to a particular religion that I know of. For example, I know that Q, that is Sri Harmandir Sahib, is a Gurdwara. Gurdwaras are definitely associated with D, that is Sikhism. So Q Harmandir Sahib and D Sikhism will go together. Harmandir Sahib is actually the official name for the Golden Temple, which is present in Amritsar. So please don't get confused. Harmandir Sahib and Golden Temple are the same religious place. So D Sikhism will go with Q. I can see another answer in the chat comment section. That is A and R. So A is Baha'i and you've associated with R, that is Lotus Temple. That's absolutely correct. Lotus Temple is a Baha'i place of worship. It is a very quaint and a quiet place. It's shaped like a lotus and is present in Delhi. Uh, because of its shape like a lotus, it has been given the name Lotus Temple. And yes, A and R are the correct matches. Then B, that is Buddhism, is associated with P, Ashok Pillar, because Ashok was a great Maurya king who was a follower of Buddhism. He was the one who propagated Buddhism in India and tried to publicize it and make it a common religion. So through these monuments like Sanchi Stoop that were being created in his time, to the pillars that were being created, he was trying to popularize the religion of Buddhism. And last one, that is S, Maitri Mandir, is associated with C, none. Maitri Mandir is a secular structure. It is actually dedicated to yoga and spirituality. It is not related to any other religion. So C will match with S, that is Maitri Mandir. So I hope that was clear. Again, this is a very interesting question. Here, an image has been given to you. In this image, a scene of a village is shown. Now, by looking at this image, you have to tell me which of the options are the correct answers. Okay, again, here you will have to choose the correct answers, and you'll only get marks when you choose all of them correctly. The given image illustrates the vernacular architecture of the Kutch region of Gujarat. So, Kutch is a desert area in Gujarat. Identify four most appropriate architectural terms and building components that best describe the architecture from the choices given below. Marks will be awarded only if all the answers are right. Now, your options are Worli art, organic, streets, Lipan art, terraces, cluster, dwellings, adobe, and landscape. So I'll explain each term very briefly. A is Worli art. Worli art is a common art form that is practiced in one of the Indian states. I won't disclose which state for now. Then B means organic. Organic means using natural elements being created very naturally and with the help of a natural and organic matter or organic resources. Then C, streets. Streets means roads. If you can see any streets or roads here, then C can be correct. If not, then it's not correct. Then D is Lipan art. Lipan art is also a traditional art form that can be seen in Indian areas, rural areas especially. And it also belongs to a particular state. Now, Worli art and Lipan art belong to two different states. Either one of them can be correct for this one, or it is also possible that none of them are correct. Please pay attention that this is related to Gujarat. So choose the terms which are specific to Gujarat. Then E is terrace. Terrace means landmass, flat land that is created by cutting a hill or a mountain. So if you can see a terrace here, then that can be correct. Then F is cluster. Cluster means a group of something. So if you can see a cluster of huts, a cluster of dwellings, then you can say that F is correct. G means dwelling. Dwelling means small residential units or small residential structures, places where people stay. Small homes are dwellings. Then H is adobe. Adobe is a type of mud construction technique. Adobe is a technique of creating mud walls by which we can make buildings. And I is landscape. Landscape means um, scenic view where you can see different type of natural elements like rivers, mountains, valleys, greenery, forest, etc. So which all can be the correct options for this one. In the comment section, I can see B and D are written. B is organic. Yes, organic can be correct because Kutch is a very rural region of Gujarat. And here you will see that most of the huts or most of the houses are made by using very organic elements like mud, thatch, wood, etc. So B organic can be correct. Then in the comment section, I can also see D, that is Lipan art. Lipan art is a traditional art form that can be seen in the villages of Gujarat. Lipan art can also be seen on the walls of these houses, these huts. You can see that very colorful artwork has been done using majorly yellow and red color. If you look at this clearly, if you Google more about Lipan art, you will see that in between this design and this pattern, mirrors are also used to decorate the walls of the houses, and this is done to radiate or reflect the sunlight that falls on these huts, so that these huts are visible from a great distance as well because of the reflecting light through the mirrors. Because these are brown colored huts in a desert, they can completely camouflage. So from a distance also, travelers can know that these huts are there in the desert. So D, Lipan art will be correct. Option A, Varli art is a traditional art form of Maharashtra. So please don't get confused with that one. Then next correct answer can be H, adobe. Adobe is a mud construction technique. There are total five correct answers in this question. B, D, F, G, H. So B, D we have discussed. F cluster, you can see a group of huts. So F cluster will also be correct. Then H is adobe And G is dwellings. Dwelling means rural houses or small huts. So G dwellings will also be correct. Then this is the next question. We just discussed about the Maitri Mandir. I think 1 or 2 questions ago. So this is the image of Maitri Mandir. It is a structure in Auroville and edifice of considerable significance. By looking at this image, identify 4 appropriate architectural terms that can best describe this building. Marks will be awarded only if all answers are right. So, as I already told you, this is a structure that is not associated with any religion. Although the term mandir is given, mandir is a Hindi term that means temple. But still, this is a temple that is associated with secularism, with yoga, with spirituality, but not with any religion. The options are buttress, organic, enveloping structures, dome, spiritual, ellipsoid, sphere, embellishment, and symbolic. Buttresses are supporting walls to carry additional load of any structure. Organic, you already know, we just discussed in the previous question. Then C, enveloping structures, a structure that is enveloped by smaller sections, smaller segments, or other smaller structures. Then D is dome. You know what a dome is? It is a semicircular or curved structure over a roof, or domes are also created as 360-degree view domes and all are also there. Then E spiritual, you know the meaning of spirituality. F is ellipsoid. Ellipsoid is actually a 3D shape. G is a sphere. H embellishment. Embellishment means decoration or ornamentation. And I symbolic. A particular thing which is a symbolic attribute, a symbolic creation for depicting something else. It can be an emotion, an art, anything. Like this can be a symbolic of yoga. In that way, symbolism. The correct answers to this question are these 6 options: C, E, D, G, H, I. C, enveloping structures is correct. D, dome is correct. E, spiritual is correct. Then G, sphere. H, embellishment. You can see embellishment in the outer facade of this building. You can see the metal work that has been done. And I, symbolic, as it is the symbolic of spirituality and yoga. So all these 6 options are correct. Now, out of these 6 in the exam, you can choose any 4. If you choose any 4 out of these 6, you get all the marks for this question. I hope that was clear. If you have any doubts related to this, please let me know in the comment section. So meanwhile, I would like to take this opportunity and tell you about our upcoming crash batch for preparation of Nata. So we take online classes for Nata. We have longer batches and then we have crash batches. As you know, exam season is on. Tomorrow, the first Nata exam for 2024 will be conducted, and these exams will be conducted till July. So if you want to prepare more nicely and if you require our help for preparing for NATA, then you can join our upcoming online crash batch. As you can see, we are discussing everything in very short manner in this live session. You can discuss everything in detail. You can ask your questions and queries in our classes, one-on-one classes that we conduct through Zoom. And these classes are for up to 1.5 hours to 2 hours. So we can discuss each and every topic in detail in these classes. So please don't miss this opportunity. A number has been given on your screen. Please note this number down. You can also contact us on WhatsApp through this number and just let us know. We'll help you ahead. So hopefully you will take this opportunity and prepare well for your upcoming exams. Now let's discuss the next question. This next question is related to a part, a component of building, that is windows. You have to tell me what is the type of window that is shown in this image. Your 4 options are awning window, louvered window, casement window, and bay window. So before discussing this ahead, I want to tell you what these 4 type of windows are. So I have attached images of these 4 types of images, and you have to tell me, sorry, you have to understand by looking at these images what each of these terms mean. So the first one is an awning window. The difference here in this window is that this window does not open sideways, but this window opens upside down. So you have to open it vertically and not horizontally. So this is an awning window. Then next one is a louvered window. In a louvered window, there are multiple louvers. Louvers are these thin fins that are attached to a window, and these fins are movable. You can move them up to 90 degrees, and when you want to look outside, when you want to get a view of the outside world, you can open these, and if you do not want the view, you can shut them. So they are slightly rotating. You can rotate them and you can shut the window. So these are louvered windows, and the thin stripes that you can see, these are made of glass or fiber or different materials. Wooden louvers are also there. So these are the louvers from which this window gets its name. Then the third one is a casement window. This window is fixed inside a casing. Hence, it is known as a casement window. And the last one is a bay window. This bay window has an additional space where people can sit in the interior, and from the outside, it is projected in three or six or five different parts. So here you can see three portions are there. There is an angle. This one smaller side is there, then the larger side, and then again a smaller side. So these type of windows are specifically used in extreme cold environments, because in such areas we want to gain more and more heat, more and more warmth inside the building. We want more and more sunlight to enter inside the building. So to increase the surface area of the opening, such type of windows are created. So the correct answer to this one will be option A, awning window, because you can see that this window is opening vertically. Is that clear? I hope after this explanation, no doubts will be there, because now you know what each of these terms mean. Right? Hopefully, there's no doubt. If there is any, of free to ask the doubts in the comments. So we'll go to the next question now after this. Okay, I think this is a question that each and every one of you can answer. You have to look at this image, and you have to tell me which monument is there on your screen. Identify the monument from the detail of an edifice given below. Here, edifice means a very large, a giant, very imposing building. So the options are Buland Darwaza, Fatehpur Sikri, Char Minar, Hyderabad, Gateway of India, Mumbai, or Qutub Minar, New Delhi. So which one is it? Can you answer? Someone has answered A. This is not A. A is not the right answer for this one. I think that answer was there for the last question, if I'm not wrong. What can be the right answer to this question? No, B is also not correct. This is not Charminar in Hyderabad. Please look at it carefully. Look at the eccentric plan of this building. It looks like a tall tower, and the shape of the building is very unique. There are some vertices that are coming out, and there are some curved walls as well. This is a very tall tower. It is present in New Delhi. The correct answer to this question is D, that is Qutub Minar. This is Qutub Minar, a tall tower that was made during the Sultanate period in New Delhi by the slave dynasty. So I hope you all have seen at least the images of Qutub Minar. So you should know this one. I was expecting that everyone would have given the previous answer. When we look at the outer walls of Qutub Minar, you can see different type of carvings are done here. So you can see some text written in Arabic. This is known as calligraphy. Calligraphy is one of the major elements that is seen in the buildings of Islamic architecture. Then you can also see some patterns have been created here. Floral motifs, floral and leaf design. So this is known as vegetal motif. It is known as arabesque, the art form that is created. So these are some different elements that you can see in Islamic buildings in India. Let's go to the next question now. This question is also quite interesting. You have to look at these four images, A, B, C, and D, and you have to tell me which among the following is not an example of subterranean architecture. So to answer this question, you first have to know that what is the meaning of subterranean architecture. Subterranean architecture is a type of architecture that is created underground. Subterranean means under the terrain. Terrain means the ground level. So you have to tell me which of these buildings are under the ground or examples of subterranean. Only one will be the right answer, which is not an example of subterranean, meaning it will be a superstructure. Superstructure means a building built form that is above the ground. So look at A, it is a step well. Look at B, it looks like something that has been created in a hillock. Then look at C, again something that has been created by cutting a rock or a mountain. And D, D looks like a built structure on top of a flat surface. So the correct answer here will be option D. D is not an example of subterranean architecture. Please don't forget this term. Here are two more examples of modern day buildings that are subterranean in form. So since the beginning of humankind, what is called subterranean architecture exists. Meaning, ever since we have started creating any sort of home for ourselves, subterranean architecture has existed. Even the earliest men in the prehistoric period created subterranean huts to protect themselves from wildlife and natural calamities. It is in fact finding shelter in the underground. The concept was once used in order to create caves, refuges for temporary use, tunnels as an answer for the most primitive needs. The most primitive needs were safety and security. Today, subterranean architecture is mystic, so you can see these two structures, very advanced buildings that are created under the ground, especially the first one. You can see so many floors are going under the ground in this building. You can see multiple floors are there beneath the ground. So these are two great examples of subterranean architecture where you can see buildings have been created under the ground level. We'll go to the next question now. Oh, I think this is repetitive. Okay, so this one. Identify the color palette of the interior image from amongst the given choices. So here you can see that some images are, sorry, one image is given on your screen. You can see some colors are being used in this one. You can see colors like blue, green have been used here. You can see a table, a small table which is having violet color. Now looking at these different colors, you have to tell me what is the color combination here. Options are complementary colors, analogous colors, triadic, and monochrome. Monochromatic color scheme is a color scheme where you will see a single color will be used and everything in the space or in the composition will be made with a single color. For example, if this was a monochromatic color scheme, then everything would be in one color. It can be different shades of blue or different shades of green or different shades of violet. These different colors would not be there. One color and different shades of the same color, like light to dark of the same color. Then see, triadic means a color combination which has three colors. We have two triads in the color wheel, the primary triad and the secondary triad. We discuss in great depth about these color combinations in our classes. Then B is analogous color. I've already told you analogous colors are three adjacent colors in the color wheel. And A is complementary color. Complementary color is a color pair, meaning it has two colors which are exactly opposite to each other in the color wheel. So can you answer me? Which is the correct option here? The right answer here will be B, analogous colors. Then this is the next question. Again, it is related to color theory. With respect to color, match the following. Marks will be awarded only if all the matches that you have done are correct. So on the left side, you will see some terms that are related to color theory, and on the right side, you will see some brief explanation of these terms. The words are AU, B tint, C shade, and D tone. And all the people who have attended my lecture before can answer this even without looking at the options on the right, because we've discussed this so nicely in our class. Then in the right side you will see add gray, pure color, add white, and add black. The simplest one is shade. Shade is always darker in color. We know shade is created by adding black. So C shade will be associated with S, that is add black. So we have one combination right there. Then in the comment section, I can see KJ has said B is matched with R. B is tint. Tint is created when we add white. So B and R will be correct. Then AU means pure color. So AU will be matched with Q, that is pure color, and D tone. Only one option is remaining, that is P add gray. So D will match with P. So in this way, you can solve such match the type questions where even if you know one right combination, you can, by deduction method, you can match the others. Let's see the next question now. Okay, so here the answers are also there. A, Q, B, R, C, S, and D, P. Now this is the next one. Again, you have to look at this image and you have to tell me the four most important visual principles or elements in the photograph given below. Marks will be awarded only if all answers are right. So that goes without saying. You have to give the four answers correctly. Options are progression. Progression means progressing, going towards something. Then B is asymmetry, the act of not being symmetric. Then C is focal point, meaning having one common point to which all the different lines are converging. So, and D, grid. E, highlight, one particular element, that is the highlight in any composition or design. Then F is pattern, a particular design repeating itself. Then G is repetition, repetition of the same elements or same design. Then H, parallelisms, when you can see parallel lines in a composition. And I is fluidity. Fluidity means the act of not being stagnant or stationary, rather looking like it is moving. So what can be the right answer here? There are five right options here. They are A, C, F, G, and H. A is progression. You can see everything that is there in this composition. All the lines, they are progressing towards one common point that lies here. I hope you can see my arrow. I'm moving my arrow to the focal area or the focal point of this composition. I hope you can see it. This is the focal point, and all the lines in this composition are progressing. This is one point perspective. If you look at it from the point of perspective drawing, the point that is there is the focal point at the center here. So A, progression, will be correct. Next will be C, focal point. Then F, pattern. You can see a pattern has been created in the arches that are there in the roof design. A pattern is, and it is repeating itself in every layer. So F, pattern, will be there. Then G, repetition, will be there because same elements are repeating, be it the doorway, be it the ceiling design. And lastly, H, parallelism, because in the ceiling you can see many parallel lines are there in the design. So all these five will be correct. You can choose any four in the exam out of such 5 or 6 correct options. I hope that was clear. If you have any doubt, please let me know in the comments. Then this is the next question. Again, a match the following type of question. Some images are given on the left-hand side and names of important destinations, important statues are given on the right side. Names of the places in which these statues are given on the right-hand side. So you have to match the image with the name of the place where it is located. Match the landmark statues with the place they are located at. Marks will be given only if all the answers are correct. So first of all, try to identify which are these statues. What is the name of this statue that is given on your screen, and then try to match it. So in these questions, what we do is, if I do not know all the four answers correctly, I start matching the ones that I already know of, and ultimately I'll get the remaining ones. So I very clearly know B, that is Statue of Unity. This is the statue of Sardar Vallabhbhai Patel, also known as Statue of Unity, that has been recently made. Only a few years have gone by since the statue was made in S. Kevadia, Gujarat. It is a place in Gujarat where the statue has been created. So B will match with S. Then next one I know is C, Statue of Liberty. It is there in New York, USA. So C will match with P. Then D. D is the statue of Christ the Redeemer, a very famous statue of Jesus Christ known as Christ the Redeemer. It is located in Q, Rio de Janeiro in Brazil. This leaves us with the last statue, A, that is present in Kanyakumari in Tamil Nadu. A student has very rightly answered all the matches in the comment section. Very beautiful. So we'll go to the next question now. So these are the matches, all the right answers. Then this is the next question. Again, an image has been given to you. You have to look at this image, try to observe all the elements very carefully, because usually it happens that the image is shown on the screen for a few seconds and then the image disappears. And just by memory, you have to answer the correct options. The given image is the interior of St. Mary's Cathedral, Tokyo, designed by a very famous architect named Kenzo Tange. Identify four most appropriate architectural terms and building components that best describe the project from the choices given below. Marks will be awarded only if all the answers are correct. So please look at this image carefully. Look at the unique roof design. You can see it is gray in color. A specific material is being showed in the roof. Then you can see this large, long window that goes from the bottom to the top, and then the ceiling is there. It has a small window in the ceiling as well. There are some lights on the wall. You can see these benches that are kept. It's a huge hall. The options are um, shell roof, roof light, exposed concrete, dais, granite cladding, parametric, stained glass, pyramid, and spirituality. So answer quickly in the comment section. Which all do you think are the right options here? Okay, students, still waiting for your responses. So these are all the correct answers. There are six correct options for this particular question. First of all, A, shell roof will be correct, because you can see the eccentric roof design. It looks almost like a pyramid, but the walls are curved. This is a shell roof, a different type of roof that is made in long span areas which do not require any columns to support it. So this is a shell roof. A, shell roof will be correct. The next one is B, roof light. You can see a window is there on the roof. It is known as a skylight, also known as a roof light. So B will be correct. Then C, exposed concrete. The walls are gray in color because they are made with exposed concrete, meaning it was made with concrete. A shell roof is a shell roof or shell wall, always made with concrete. But in this one, they have not plastered or painted the surface. They have kept it exposed. So C, exposed concrete will be correct. Now D, that is dais. You can see a dais is kept here from where the sermon will be read out or the priest will say something. So the dais is a holy place that is there in the altar of the church. Dais will be correct. Then next one will be G, that is stained glass. So this long window that you see from the floor to the roof, this is a stained glass window, meaning it is a colorful or a painted window. It has some color. It is not just simply transparent, but it has some color or some design on it. So that is a stained glass window. And H, pyramid. As I already told you in the beginning, this building looks somewhat like a pyramid. So that will also be correct. Then we'll go to the next one. So this is a very famous building designed by Le Corbusier. The given image is that of the High Court building, Chandigarh, designed by architect Le Corbusier. Identify four most appropriate architectural terms and building components that best describe the building from the choices given below. Again, marks will only be awarded if all the answers are correct. You can see some options like piers, organic, deep overhang, informal, shading devices, ellipsoid, exposed concrete, embellishment, and modular. There are exactly four right answers to this question. A, C, E, and G. I'll also explain you why. A is piers. You can see these vertical support systems that are there. These are the piers in this building. A piers will be correct. Then C, deep overhang. Deep overhang means a extra long ceiling that is coming out than the building, somewhat to an extra length to protect the building from excessive sunlight. Then E is shading devices. You can see different type of shading devices are there in this building to protect the inner environment from the harsh sunlight that falls on the building. These shading devices can be understood in the form of this deep overhanging roof, these vertical piers, or the recessed windows, which are covered by these projections so that direct sunlight cannot enter the building. And last one is G, that is exposed concrete. So Le Corbusier was actually a modernist architect. One of the main features of his design was exposed concrete work. You will see that most of his buildings are gray in color or white, somewhat whitish, because they are all having exposed concrete walls. They are not plastered from above or no paint is there. In fact, he leaves his walls very raw to show the exposed concrete, which is a very important feature, a very significant feature of modern style of architecture. Then this is the next question. We are there with the last two or three questions now. The given image is a section of Sangat, Ahmedabad, present in Ahmedabad, which is designed by architect V.V. Doshi. You have to identify four appropriate architectural terms and building components that can be best understood by reading the section. So a section of that image is given, section of that building is given on your screen, meaning the building has been cut open for you all to look at. By looking at this section, identify the correct answers. Options are rainwater gutter, columns, vault, dome, subterranean, grill, light shelf, geometric patterns, and retaining wall. So there will be five correct answers to this question. A, rainwater. You can see a rainwater gutter here in this section. Then option C, vault will be correct. You can see a vault roof here in the form of this semicircular. A semicircular arch only converts into a tunnel or a barrel vault. So vaulted roof will be there. Then E, subterranean. Some part of this is under the ground. You can understand by looking at this retaining wall, which is showcased by black color. Retaining walls are strong walls that actually protect the building from the surrounding mud or moisture or any other organic matter that is there under the ground. So subterranean will also be correct. Then G, light shelf will be correct, and I, retaining wall will be correct. Now, this question is somewhat different from whatever we discussed till now. This will be the last question for this live session. You have to carefully look at this image given on the screen. This image will disappear after 30 seconds, and then you will have to answer depending on what you observed in this image. So kindly look at this carefully. You can see a pathways there. Someone is riding a bicycle. Some people are sitting on the benches that are there on the side of this pathway. Now I'll show you the question. First question is, what is the predominant color of the street furniture? What is the color of the furniture that was given? So can you tell me what was the color of the furniture that was there on the side of the pathway? Yes, the right answer will be yellow. The side furniture is given in yellow color. Now, what the next question is? What is the color of the bicycle pathway? I told you that a man was riding a bicycle on the pathway. So you have to tell me what was the color of the pathway, pink, green, blue, or yellow. What will be the right answer here? What was the color of the pathway? These kind of questions require very sharp memory and good observation. You can achieve that by practicing over and over again. You have to actually pay attention to the image that is given to you. If you pay attention to the image, you can definitely answer such questions. The color of the bicycle pathway was green, as you can see here. So I hope you were able to answer these two questions correctly. Again, a similar question is there on your screen. You have to look at this image and you have to tell me the answer to the questions that will follow after 30 seconds. Okay. Carefully observe the given image depicting the interior of living room. So here the interior view of a living room or a hall of a house is given. The room has a large window and a wall which serves for display as well as TV. The furniture is minimal and formal. You can view the image for 30 seconds, after which it will disappear. You will then answer two questions based on the image. So look at this image for a few seconds. I like the fact that you are showing active participation in the comments as well. Some of you have been actively commenting and answering. That's really wonderful. Shows me how interested you are in the learning process. So now I'll show you the questions. What is the color of the curtains? I don't know if you paid attention to that or not, but there were curtains that were hanging in front of the window. So you have to tell me the color of the curtain. Four options are beige, blue, green, and white. The correct answer to this one will be B, blue. I'm showing the image again for your reference. So here you can see the blue colored curtains hanging on the window. The next question is, how many niches are there on the wall on the right which display the artifacts? So on the wall where the TV was there, the television was there, there were some niches that had some artifacts that were being showcased, that were kept in the niche. So can you tell me what was the number of niches that was there on the wall? Can you let me know in the comments? Number of niches that was there on the wall in the previous image. It's very easy. I really hope that you noticed it because the questions will be like this only. They will be very easy, but you have to notice it quickly within 30 seconds time frame. So such questions are very commonly coming. Even in the last year Nata exam, these type of questions were there. The right answer to this one is 3. There were 3 niches in the wall. I am showing you the image again. You can see there are 3 niches in which artifacts are kept. So 3 will be the correct answer. Now we'll go to the next question. I think we can take 1 or 2 more questions before Shantanu sir joins. Let's utilize this time and learn some more. You have to identify the monument from the detail of an edifice given below. Edifice again means the image of a large monument. Options are Kailashnath Temple, Ellora, Suryakund, Modhera, Sun Temple, Khajuraho, or D. Brihadeshwar Temple, Tanjore. Now, this can be a tricky question for some people. The right answer to this question will be Sun Temple, but not Khajuraho. It will be in Konark. So this was a mistake in this question. It was a typing error that came. So whatever, if you have these type of questions where you feel that the answer is incorrect, try to attempt the question because if the options are incorrect, you get bonus marks for such questions. So with that, I'll be concluding all the questions that I want to discuss with you all. I tried to bring a variety of questions in this session from different years of NATA exam so that you get an idea of various type of topics that you need to study about and various patterns of questions as well. I want to remind you again of our upcoming crash batch that starts from 8th of April, where we discuss all these topics related to architectural awareness in great detail. in these sessions, your doubts are also cleared, the topics are discussed in great depth, and we also solve many previous year question papers as well as mock test papers to prepare well for the coming exam. So without any further ado, please note down this number that is there on your screen and contact us. Now I'll be ending this architectural awareness session and I'll be handing over the session to Shantanu sir. He will be taking a live session on drawing and sketching for Nata. Over to you, sir. Thank you, students, for your attention. I am architect Nishtha Joshi. I hope to see you all in the crash batch that is starting from 8th of April.
Okay. Thank you so much. So first of all, welcome all. Hello, everyone. Hi. Those who are attending this live session today. So right and straight away, I would take you towards my drawing screen. And I hope, first of all, I'm audible properly. So topic that we are discussing today in this live stream is about two-dimensional entities and 2D composition. So based on a question that has previously appeared, so just to have a great idea about how 2D composition is done and how you should approach towards such kind of a questions. Okay, so I'm moving towards my drawing screen. So first of all, I hope all of you are able to see my screen that is I'm sharing. And first of all, let me just I hope it is visible what I'm drawing over here. Okay, so the question that has appeared previously is create an aesthetically pleasing 2D composition using only parallelogram. So first of all, whenever the question appears, isolate the various information. So first information is all about 2D composition. Using only parallelogram is the second. Third information is various sizes. Okay, so basically you can vary the sizes. You can change the scale of it. The number of shapes should be between 10 to 20. So the minimum to maximum. So there are multiple informations. Okay, so need to isolate first. So what you should do is, like, first of all, write it down. So you have to what you are supposed to do is you are supposed to create a 2D composition with the help of only parallelograms. Write it down or quickly, roughly note it somewhere that you are able. So your brain starts analyzing things and starts working on it. So it needs to have a information quite simplified so that it within a lesser time, because you have very less span of time to go to an approach to this question. So we will try to simplify the information. Okay, so various sizes, so probably we can scale it up and down, change, like all scales can be different, scale it basically. Okay, another one is like the number of, you can multiply the number of the same parallelogram. Either it can be minimum is like, let's say 10, we can max go to 20. So it can be in between also, like 15, 17, 18, 12, 13, 14, whatever. Okay, so it should vary from 10 to 20 basically. So understand that. And the last one is basically you're supposed to color it and use any 4 color of choice. So they have not mentioned, and they've just said like colors of choice. So we would try to be more conscious. So we are creating a composition. So compositions are better and harmonious if we use color schemes. So we would be able to emphasize the theme or the subject that we are delivering through this 2D composition. So when we are doing in a color segment, we would try to approach towards the various color schemes that we have. And now there's mentioning 4 color scheme, 4 colors. So basically, we would obviously use something like more, tetradic sort of a color scheme. So where we have 4 colors and we're able to create a very interesting contrast. Okay, so we'd approach with the color schemes for this. So first of all, let's understand what parallelogram is. Parallelogram is this, like something that you see a square or a quadrilateral in perspective. Okay, so where the multiple lines are parallel to each other. Okay, but the opposite sides, basically the opposite sides are parallel to each other, and we are supposed to create a composition out of it. So this is an approach that we have had. Now let's move on. Let's understand this composition can also, have something interesting. It can have a certain continuity, a certain, like we would just build a small frame quickly. So we are able to make a thumbnail or a quick sketch in this, and then we can move further and to design and, for example, say develop the sketch further. Okay. So we can also use various principles of design, just to create the, composition. So for example, like I'm just drawing one parallelogram here. Okay. Now, for example, this is the entire worksheet. So what I'm going to do is maybe just to create something, or maybe to, create a balance in the composition, I'm going to draw one. Okay. So here we are done with our two. So you can see they're absolutely in one size. Okay. Or we can obviously change it. Okay. Now, probably we can also overlap. The composition is always about that. So probably we can take. Now, this is very generic, or even if we don't overlap, let's say if we are just colliding them, keeping them quite adjacent to each other, fine. So I'm going to create a very asymmetrical balance. So where, opposition is the key. We are trying to create something interesting. So, okay, we have just used 5 of the parallelogram. So this is my, probably kind of a composition that I wish to deal with. Okay, maybe I would draw another one which is smaller, maybe like to show a continuity from one end to another. So I'm just using very simple principles of design, aesthetics, creativity, and I'm just trying to deliver this. So this is one sketch. Okay, and now maybe we can also create something now, probably just to break the entire like monotonous approach in this. We can also add, you see, we can change it, like probably fine. Now this is the composition. Maybe where we have used a very simple composition, and it is like continuity and rhythm, basically rhythm by opposition, balance with asymmetry in it, or continuity, or like fluidity or continuity from one edge to another. So we have used a very simple composition. Probably we need to first of all draw multiple iterations. So make key sketches. Okay, key sketches is quite essential. So we can actually work on a various compositions if we are able to deal with multiple key sketches very quickly, so that we are able to see which one works better. Or probably let's try to create something very interesting. And this line is just for me to create some rhythm or some harmony. I'm gonna follow this. I want to create something more fluidic. Okay, so for example, let's keep something over here. Now this is the parallelogram that I wish to have in the beginning. Maybe we can, like you see, this is also a parallelogram. Now I want to create something very geometrical. Let's see if we are able to do so. But we want to create something like very harmonic. Now I'm just trying to use something that is more we are just trying to create various compositions. Fine. So this is like maybe one of the composition that we wish to explore, which speaks about continuity, harmony, rhythm, or probably, uniformity. We just kept one size in this, and definitely we can change as many as things, or probably, you would say, uh, the patterns. We can also go into tessellations. Like when we are discussing this, I'll just show you what tessellation is, where we are considering, basically, these parallelograms are like units, like how prints are done on fabric. So we can create a motif out of it, which we can actually draw in 2D, but we can also show it that we are drawing something three-dimensional. Okay, let's draw it together. Just a moment. So this is another one. Let's create something, more. Fine. So we can also discuss something, okay, like a, if I show you this, yeah. So simple, like for example, like a print, it can be dealt with something very simple like this, like a repetition, where, okay, it's like, for example, like how if a chessboard may be then copied, or this becomes one unit. Okay, for example, this is one pattern. Now if we repeat this, it becomes a probably a tessellate it, or maybe change the scale of it. Okay, so that is one possibility. Let's see. Let's create multiple compositions first of all before we end up like coloring it, or So for example, this is another one. Like we have been able to repeat. So this is a simple tessellation. Now, for example, if we like take it to a half scale of it, where we are able to, we're just able to repeat it so interestingly that we are able to just, maybe, or put, or the exactly half of it, and maybe we are able to put this in such a place where we are able to change the entire iteration of this. Now probably this is one pattern, and maybe if we copy this, you see we are also able to create something very interesting, something very very creative as well. Okay, so not necessary that it has to have the connectivity that is required, like for all the, probably this can also become a very interesting composition. Now what are we trying to do is, we are trying to use a repetition as a key, and we are trying to create a harmony. Okay, so basically what is harmony? So basically a similar shape but of different sizes, and they are bounded by unity and the concept of variety altogether. Okay, so that is something that we can discuss, or probably one can be broken, or probably we can also use emphasize by just creating one. So this is my another composition. Fine. Okay, let's just speak about one that is quite simple. Now for example, what if we just want to simply create a continuity for an eye, or maybe emphasis, or maybe a gradation. Okay, what is gradation? So basically we are increasing one. Now maybe this is the like simplifying, like sort of a formula we are using. This is the double size of it. Maybe we emphasize this. Okay, but yeah, this eventually becomes even bigger, like the double the size of this. Okay, it gets even bigger. So now what are we trying to do is, we are trying to get at a continuity in such a way where I is being treated with the continuity, so that it understand the transition that is being generated for an eye. Now maybe we can also use something like crosshatch. Now since this is dark, I'm just showing the possibilities of with the composition. Now probably this can get lighter. even lighter. Why? Because if I place light values in this would this would just disappear with the powerfulness. If I just paint this completely black, obviously the more emphasis would go on this, and this would be neglected. So probably we are doing the reverse mechanism. Okay. You see? So basically my eye now moves from lighter to darker, and probably still this is getting noticed. So in my composition, all of my the particles or the elements that I'm using, you see, they should get they should be noticed basically, right? So now tessellation plays a very interesting approach, a design. There are many ways we can deal with it. Now the parallelograms can get somewhere, like parallel also. We can use a three-dimensional grid, or what we call it as a isometric grid, just to create this composition. I'm just trying to show you the best possibilities. Now what I'm going to do is I'm going to quickly, just a moment, I'm going to quickly make a grid. You see, I'm going to quickly draft a grid for you. Okay. Now probably I have it like drafted. What I'll try to do is I'll just bring it, or probably let it do. Let's just draw it so that you guys are able to understand. So basically that at the angle of say like 45 degree to each other, or a 30 or 60 degree to each other. So we're just building this grid. Okay, let's just quickly deal with it. Okay. Now same the opposite lines. So what I'm gonna do is I'm just gonna repeat this. Use the potential of using the digital media. Okay. So just quickly using this. Okay, fine. Now okay, fine. So this is the grid that we wish to use. Now, probably let's consider this as something like a three-dimensional grid too. Now, probably the moment when when I add vertical lines to this, you see, what are we able to do is we are able to introduce the concept of three-dimensionality. Okay, I'm just quickly roughly doing this. So what you can do is like you can get something like a interesting print of it, and probably practice this and create your own compositions. Okay, now probably let's draw something on top of this. Now if you see, like in vertical grid also, like if I place, I would be getting this parallelograms. Okay, I'm just using the grid. So this is like one unit that we are absolutely aware about, or probably we can just deal with a very different direction. Let's see. Let's just call. Okay. Now obviously you see these two lines are parallel to each other. So basically it becomes a like sort of a parallelogram. Fine. Okay. Now what I'm going to do is I'm going to use a grid in the same direction. Maybe see this like two lines are parallel. Just using the grid for the horizontal lines, and now this suddenly it starts giving you the appeal of three-dimensionality into your concept. Okay, now probably the moment I introduce, now maybe this is one pattern. Let's just observe what it is sort of it is able to help you. It is able to create things for you. Okay, fine, just simple grid. Now the moment I'm able to hold this, now see suddenly it is giving you something more three-dimensional, something very interesting as you just copy it somewhere. Yep. Okay. So just trying to Now you see we can use this this as a interesting grid. Okay. Now the moment when I'm introducing colors to this, you see the whole subject can get more interesting. Now when we are using color schemes, for example, let's use a certain color. I'll just fulfill this, okay, just to show you right now, like what we are willing to do with this. Okay. Now we want to introduce a color scheme. For example, let's call it a triadic, tetradic, or quadrilateral or square color scheme. Like for example, okay, I'm just bringing this color wheel for your understanding. Okay. Now, when I'm introducing color to this, you see, quadrilateral or a square color scheme is basically using 4 colors into the into this particular palette. Okay, so let's split complementary. The next version of the split complementary is a tetradic color scheme. So where we are using, let's just, I'll show you. Like probably if we leave one color, okay, let's say this 2. Okay, let's use some darker color. This 2, I'm gonna use this tertiary color, okay, and then this 2 tertiary color. So this becomes a rectangular color scheme. So it's like quite a extremely interesting as a quadrilateral, and like simply split complementary, okay, on both the sides. So it becomes quite easy to draft. It becomes quite easy to observe also. Another one is like we can take a primary color, drop 2 colors in between. Okay, you see, drop 2 colors in between, and then we can actually take another secondary, drop another 2. So this is a square color scheme. So basically, if you observe, colors that are appear in this are quite vibrant, okay, to each other. You see. So what we can do is we can use this color scheme to paint this, and we can absolutely use the tints, tones, and shades of this to make this color scheme very interesting. Okay. Now 2D composition is not it is not as intimidating as it sounds, but we can create something very interesting. You see. Now what is tint? When we add white to this, it becomes a tint. When, like for this blue, for example, okay, like if this is the blue, I'll just help you here. See, on this side, if we have white, if we add white to this, it becomes the tint of this color, you see. So this becomes a tint of it. The moment I add black to this, it becomes the shade of it. The moment I add tone to it, like I mean gray to it, it becomes the tone of it. So we can not just paint one object with just simple color, but we can also use its tints, tones, and shades. Okay, so let's just quickly do that. Okay, and probably we can use one line. Maybe this is one color. I'm just, okay, maybe this is the shadow side of it. Okay, fine. Now this is what, like the pure saturation of it. I'm gonna use a shade, okay, shade side to this. You see, it is quite different from that. You would be able to quickly see it. Now light is been from the top, so I'm roughly doing this now because time, I have a very limited time to do so. Now suddenly you are bringing the concept of with physical perception, a 3D-ness in 2D as well. Okay, you see, the things that we are drawing is 2D, but still we are conveying something that is 3-dimensional. Now probably let's take this, okay, like maybe I will use warm colors in this segment. Okay, maybe this green is not warmer, but yeah, probably the moment if I go towards, like probably more yellowish green, probably this becomes warmer. Okay, you see, this is quite a warmer green. Now I'm gonna use the shade of this just to show. Okay, so this is the shadow or shaded side of it. The moment I go to the tint of it, okay, it shows that, okay, probably I'll add more white to this. Okay, so this becomes the tint side of it. Now the top line probably speaks about that warm colors in nature, and maybe you see, I will take Maybe this is the shaded side. Obviously you can, this is, I mean, not to influence you, but yeah, probably what you can do is you can take your own call. Now probably I can use something like more, say, a cooler green also. Colors are the same. I'm just trying to use the hues and tints of it. Okay. Now you see, like the tint of it, it is quite brighter. You see, we are just creating a very interesting visual perception. Okay. And let's use, like, for example, shade of it. Now, probably, this is the concept. I can bring in something more interesting. I'll just show you. If you have time, you do so. Otherwise, forget this. Okay. I'm going to use a dot stippling over just to create more interesting gradation. Okay. Just adding this over here. Okay. Maybe using the opposite to create something interesting. You see, the opposition works so amazing and fun. It becomes a very interesting aspect. Okay. Now, probably just a second. Yeah. Fine. So we can just create, as an opposition to this over here. Maybe like there is like a dotted, okay, texture stippling, or maybe just using the brighter one, maybe using the dark one on this one. Same thing, like using the brighter one on this, using the dark one on the both of this. Okay, you can create very interesting visual. Now, what is it trying to do is, it is trying to give your vision a very interesting pull, a very interesting flow. Because see, what we just have created is a solid two-dimensional entity, but with the use of hues and with the various tints, tones, and shades, we are able to generate something totally. And what we can do is, like, we can call this a very interesting sort of a print on, like, maybe say a bag, or maybe say a fabric, whatever. Okay, so the implementations are quite vast. Okay, but what you create out of it, it is quite the the fun, the most interesting fact. So the compositions that we created, let's just quickly have a look at them. Okay, you see, like, simple continuity. We created way more, the rhythm, harmony, and fluidity for a vision. Another one that we created in a randomness, but we can also tweak something interesting. Like, probably the moment I introduce a large parallelogram over here, suddenly my emphasis is gonna go on that. So emphasis. Maybe even if I paint one with, like, very purely red color, okay, you just observe the entire vision. Okay, my entire line of action goes over there. Okay, so basically what we see is this color. So emphasized a certain entity where you want something to be in the focus. Okay, so that is another way we can deliver the composition. Another one is simple continuity. Okay, simple hierarchy, or simple gradation and transition, where things start getting bigger gradually, but they also start reducing gradually at the same pace. So we are using the principles of design, elements of creativity in the composition to deliver. This is not a rocket science, keeping it simple, but we can deliver the compositions in a very interesting and abstract manner. Okay, and where we can go towards, like, even if we wish to create something which looks like a three-dimensional out of tessellations, or using the grid of isometric composition, we can create interesting visual compositions in 2 dimensions by using just one and only one shape, which is a parallelogram. Okay, fine. So I hope you enjoyed it. I hope it was helpful. But yeah, definitely for your Nata exam, such compositional questions related to maybe say 2D or 3D would appear. I hope you have understood it. Rather than getting intimidated about it, I would say use a rough space, quickly understand what you wish to deliver, and start working on it. Fine. Okay, so I'll stop over here now. I'll hand over to the host. I hope you enjoyed the session. I'm Shantanu Salunke, an architect and a designer, and hope to see you soon. And I hope you you do wonderful in your exams. Okay, thank you so much. Thank you so much for joining. Bye bye.